work is dispatched on certain day. This is how it is called. Again, this is a retrieval augment generation kind of a architecture. So from the left side, you see that the doc. This is your enterprise document. Imagine this is your HR policy document. You feed this document to the embedding using the embedding model. Some model that will convert this PDF file into the chunks and then convert this into the numerical representation called vectors, which we call it embedding. They store it into your private vector database. This part is totally private, right? Now here, the users, this is your chatbot application. Let's say this is your AI application. The user will ask the question, tell me my leave policy. The chatbot here will query the private database, which is in your enterprise company. Then this will retrieve the information, like let's say the leave policy 35 days, and then feed it to the LLM as an augmentation. It contains two things. One, 35 days of the leave policy, the information which has been retrieved, plus the query also gets embedded into the vector database. Then it send it back to the LLM, and LLM will respond. This is the policy of your leave. This is how the policy of whatever information, right? And this is how this entire process goes. It's a very simple architecture, I would say. A very complex architecture, but I will not go deep into it. Guys, समझ आ रहा, कुछ प्रॉब्लम तो नहीं? Am I too loud? Too fast? Clear? All good? Okay. जो सुना रहा है बता देना। बोर हो रहे होगे, लोगों को अच्छे जोक्स आते हैं, शायरी वारी भी आती है, बता देना। चलो ठीक है, एम्बेडिंग के ऊपर थोड़ा बात करते हैं, ठीक है, थोड़ा हिंदी में बात करते हैं अपनी मातृभाषा में। तो एम्बेडिंग क्या, मैंने अभी पहले बताया ना, एम्बेडिंग क्या है, व्हाट इज एम्बेडिंग? एम्बेडिंग कुछ नहीं है, एम्बेडिंग क्या है? न्यूमेरिकल रिप्रेजेंट। ये फ्लावर है, ये फ्लावर दिख रहा है आपको? इस फ्लावर की कुछ सर्टेन एट्रीब्यूट्स हैं। इसकी खुशबू बहुत अच्छी है, इसके जो लीव्स हैं ये व्हाइट हैं, अंदर का ये जो बीच का दिख रहा है ये येलो है, और ये बाकी सारे जो एट्रीब्यूट्स हैं। तो इस इमेज को, अगर आपने इस इमेज को किसी ए एप्लीकेशन से पूछा, यार इस इमेज की क्वालिटी बताओ, या इस इमेज का बताओ कि लीव्स कौन से कलर का है, कैसे पता चलेगा? ये जो आप एट्रीब्यूट्स है ना, ये न्यूमेरिकल रिप्रेजेंटेशन में स्टोर होते हैं। 1.3 ये सब न्यूमेरिकल रिप्रेजेंटेशन क्या है? वेक्टर है। जो क्लोजेस्ट नंबर होते हैं ना, वो आपस में एक डायमेंशन में स्टोर होते हैं, और जो बाहर जो दूर के होते हैं डायमेंशंस, जो दूर के न्यूमेरिकल जो नंबर्स होते हैं वो थोड़ा सा सेकंड डायमेंशंस में होते हैं। तो इसलिए जब आप किसी भी एलएलएम मॉडल में क्वेश्चंस पूछते हो ना, तो वो फटाफट आंसर इसलिए करता है क्योंकि उसको पता है कि मेरे जो क्लोजेस्ट फैक्टर्स हैं उनको कैसे फाइंड आउट करना है। न्यूरल नेटवर्क ऐसे ही काम करता है। बहुत सारे मॉडल है, ट्रांसफॉर्मर मॉडल है, न्यूरल मॉडल है, इस पर बात नहीं करेंगे। जैसे ब्रेन होता है, हमारे ब्रेन में कितने न्यूरॉन्स होते हैं? आपको पता है किसी को कितने? करोड़ों में है, छोटे। जब आप कोई आपसे कोई क्वेश्चन करता है, जब आप अपना दिमाग लगाते हो, तो वो न्यूरल आपस में इंफॉर्मेशन पास करते हैं। सेकंड्स में काम होता है, मिली सेकंड्स में। यहाँ भी मिली सेकंड्स में होता है, ठीक है। वो न्यूरॉन्स जो है ना, आपस में इंफॉर्मेशन बताते हैं कि क्या है आपका, आप जो बात कर रहे हो क्या वो इमोशनल है, हैप्पीनेस वाला है। तो वैसे ही कुछ एलएलएम उसको एनालाइज करके रिस्पॉन्स करता है, ठीक है। So we are done with the lightning talk. Any questions so far? Anyone? Don't be shy. Yeah, please.
So I want to ask
Yeah. So I want to ask. So you mentioned the speed of this neural system is very fast. So how do you want to compare it, like this RAG system and this, neural network system and the brain speed? Which one is fast?
नहीं, I think आप कंफ्यूज हो यहाँ पे। न्यूरल नेटवर्क जो है वो जनरेटिव एआई मॉडल का एक ब्लूप्रिंट है, जिसके ऊपर ये पूरा मॉडल बना है, ठीक है। न्यूरल नेटवर्क क्या है? ये एक ब्लूप्रिंट है जिसके ऊपर आपका ये पूरा एलएलएम मॉडल तैयार होता है। उसमें हम डिफरेंट डॉट्स को कनेक्ट करते हैं। रैग जो है ये इसके बाद आता है, रैग का इससे कोई लेना देना नहीं है, ठीक है। न्यूरल नेटवर्क अलग, आप इसको पढ़ना थोड़ा सा और डिटेल में, क्योंकि मैं अभी वो स्लाइड्स कवर नहीं कर सकता, हमारे पास टाइम थोड़ा कम है जो वर्कशॉप में करनी। तो न्यूरल नेटवर्क का फंडा अलग है, रैक का फंडा अलग है। रैक का सिंपल मतलब ये समझ लो कि आपका जो प्राइवेट डेटा है ना, उसकी इंफॉर्मेशन आप एलएलएम को दे रहे हो ताकि वो आंसर कर सके, ठीक है। आप चैट जीपीटी को पूछो मेरा बर्थडे कब है, बताएगा वो? आप पूछना कभी, आप पूछना मेरी गर्लफ्रेंड का नाम क्या है, बता देगा? कभी नहीं बताएगा, उसको पता ही नहीं है।
बताया था उसने,
अब बता दिया था क्या नाम था?
हैनी।
हाँ है नहीं सही, तो तुम कह रहे हो बता दिया था।
Actually, my question was about the speed of this neural network and the brain.
नहीं, स्पीड का देखो, स्पीड का हम बाद में बात करेंगे, ठीक है। और आप मेरे से 1-on-1 कनेक्ट करना ऑफलाइन ड्यूरिंग द लंच, आई विल हेल्प यू। अभी कॉन्टेक्स्ट थोड़ा डिफरेंट है ये।
The classic example is
For the updated information, I think we have MCP servers.
फॉर न्यूरल नेटवर्क,
For not for neural networks, for general AI agents, we have MCP servers to get the latest data fetched from the internet or whatever your application is.
या वी हैव एजेंट्स, रैक बेस्ड एजेंट, डेफिनेटली यस, यू आर राइट। सो वी कैन गो फॉर द एजेंट। यस सर, आप कुछ बोल रहे थे।
I think the real life classic example is Tesla, which is using neural networks, right? Vehicles and everything along with agentic AI.
No sir, actually neural network is the base for the generative AI model. आपका जो LLM मॉडल बना है उसका बेस क्या है? वो मॉडल को आपने ट्रेन कैसे किया है, उसके लिए आपके पास ब्लूप्रिंट्स होते हैं, उसमें से एक है न्यूरल नेटवर्क।
I agree, but there is an automation car as well, right?
Right.
So there is some AI behind.
You are talking about regression, class, like there are some machine learning types which is called a regression.
This is kind of a driverless car.
Exactly. There you can say yes. There is neural network. Exactly. So yeah, you are right.
So this is something kind of a real life example which I'm trying to put.
You can say that there you can say there are some neural network comes into the picture, क्योंकि टेस्ला की कार जो है,
Which requires minimum human intervention, right?
एग्जैक्टली, क्योंकि टेस्ला की जो कार है उनके पास कैमरे और सेंसर्स लगे होते हैं, वो पूरा एरिया को एनालाइज करते हैं और एक साथ जोड़ते हैं, न्यूरल नेटवर्क बोल सकते हैं वहां पे, और उस बेस के ऊपर फॉल्स ट्रू एंड फॉल्स समथिंग कुछ फॉल्स समथिंग कुछ उनको रेटिंग दी जाती है कि नहीं भाई, अगर ये मेरी गाड़ी दीवार में घुस जाए तो वहां पे आपकी रेटिंग खराब है। तो उस बेस पे रिग्रेशन मॉडल तैयार होते हैं, क्योंकि फिर नेक्स्ट टाइम टेस्ला को पता होगा नहीं यार मेरे को इस तरफ नहीं जाना, यहाँ वॉल है, मुझको नेगेटिव पॉइंट मिल जाएगा, मेरे को पॉजिटिव पॉइंट की तरफ जाना है। पॉजिटिव पॉइंट क्या है? सामने रोड है, राइट मुंड है, लेफ्ट मुंड है, वो सारे पॉजिटिव पॉइंट है। जैसे बच्चों को समझाते हैं यार ये गलत है, यहाँ नहीं जाना है, फिर नेक्स्ट टाइम उसको पता चल जाएगा हाँ मुझे यहाँ नहीं जाना है, यहाँ पे खतरा है, मुझे स्टेज पे नहीं जाना, मैं गिर जाऊंगा। तो उसको ये बताना आपको ऐसे जाना है, लिफ्ट से जाना है, तो उसको माइंड में ना अच्छी चीजें और गलत चीजों का पता चलता है। ऐसी रिग्रेशन मॉडल आपने सही बोला, न्यूरल नेटवर्क को कनेक्ट करके ये चीजें फाइंड आउट करता है। आई होप इट्स क्लियर। यस।
So as of today, the use case that you mentioned, the Tesla auto car. So we need to train that thing on the real data as of today. But just to mention that there is a new thing from NVIDIA that is Neoverse. So that's a virtual world, and you can put your AI agent or you can say machine learning model there, and it will feed your model with the artificial data and it will train over it. So उसके बाद होता क्या है कि आपका जो रियल वर्ल्ड वाला जो ओवरहेड था कि आपको रियल वर्ल्ड के डेटा से उसको ट्रेन करना होगा, वो काफी कम हो गया। So it's a latest news on the.
Okay, thanks for this information. See, दो चीजें बता रहा हूँ मैं आपको। जब हम बात करते हैं मशीन लर्निंग की ना, ये मॉडल कैसे बनते हैं, इट्स अ काइंड ऑफ मशीन लर्निंग। आप अगर आर्टिफिशियल इंटेलिजेंस का अगर आर्किटेक्चर देखो तो पहले एआई आता है, सबसे ऊपर टॉप पे एआई आता है, उसके बाद क्या आता है? मशीन लर्निंग, उसके बाद ये जेन एआई मॉडल, डीप लर्निंग। टॉप पे एआई है, फिर मशीन लर्निंग के अंदर ये सारे आते हैं। आप अपना खुद का भी जेमिनी मॉडल बना सकते हो, जैसे ये चैट जीपीटी ने अपना जीपीटी मॉडल बनाया, आप बना सकते हो, पर कैसे बनाओगे मशीन लर्निंग, विच मॉडल, जैसे आपने बताया रिग्रेशन मॉडल, क्लासिफिकेशन मॉडल, ये सारी टेक्निक है बनाने के लिए। तो मशीन लर्निंग क्या है, अगर आपको भी अपना कस्टम मॉडल बनाना है अपनी नीड के अकॉर्डिंग, जैसे अभी आपने बोला ना एनवीडिया का वो पूरा, उन्होंने अपने कोई कस्टम मॉडल बना रखे होंगे क्योंकि उनकी रिक्वायरमेंट अलग है। बिहाइंड द सीन उन्होंने एलएलएम भी लिया होगा टू जनरेट द कंटेंट, दोनों चीजों को मिक्स करके क्लासिफिकेशन मॉडल पे जाओगे, आपके पास सुपरवाइज लर्निंग है, डिफरेंट चीजें हैं, उस पे हम बाद में जाएंगे। तो अभी आई थिंक वी हैव 40 मिनट्स लेफ्ट। गाइस, any confusion, anything else? Yes,
I have the question from the previous slide.
previous slide. Okay.
So in the vectors is what I understand from the vectors are the point in the space and they are used to map the information in the database kind of thing. So there are numerous vector points as well. So how we map instantly from particular this point will be helped to get particular information. Is there particular algorithm also?
No algorithm. See, embedding models, they have their own model. You can use Gemini embedding model 2.0. You can use OpenAI embedding model. You can use any model to create the embeddings. Embeddings क्या है, मैं short चीज में short आंसर बताता हूँ। ये dimensions होती हैं कुछ, ठीक है। अब यहाँ पे king है, फिर queen है, और ऐसे related उसका son है। तो ये चीजें ना आपस में एक वेक्टर रिप्रेजेंटेशन बनाएंगे, इसको नंबर मिल गया 1, इसको 1.1, इसको 1.2, ये नंबर आपस में क्लोजर है। तो ये जब भी एलएलएम रिस्पांस करेगा ना, तो सबसे पहले इन नंबर्स को पिक करेगा, ठीक है ना। तो कुछ नहीं है, टेक्स्ट को हम ना एक एम्बेडिंग में कन्वर्ट करते हैं, नंबर्स में कन्वर्ट करते हैं। आपको पता है गूगल सर्च जो है वो भी यही करता है। गूगल आप यूज करते हो, जब आप जैसे सर्च करते हो फटाक से इंफॉर्मेशन आ जाती है, कैसे आती है, टेक्स्ट की एम्बेडिंग होती है न्यूमेरिकल में, और न्यूमेरिकल जल्दी सर्च होता है, सिमेंटिक सर्च जिसे बोलते हैं, ठीक है। बस वही है यहाँ पे क्लोजर वर्ड्स जो है, जो इसके जैसे मैंने अभी बोला ना, तो मैंने जो बोला है, जो वर्ड एक साथ बोले हैं, मुझे क्या बोले, वो वर्ड जो है ना आपस में एक साथ आए थे, एक डायमेंशंस में आए थे। तो एलएलएम क्या करता है, उनको जल्दी से फाइंड आउट करता है और आंसर देता है। क्लियर ना? बाकी देखो, अगर आपको इस पे और जानकारी चाहिए तो आप मेरे YouTube चैनल पे ना बहुत अच्छी वीडियोस हैं, न्यूरल नेटवर्क पे भी है, डीप लर्निंग पे भी है, आप एक बार जाना उस पे और थोड़ा सा उसको और अच्छे से रीड करना, सब क्लियर हो जाएगा, ठीक है। यस,
hello. So yeah, my question is actually related to when you're talking about RAG and the problems that we're trying to solve is the context problem. So generally what we do is we pick up the transformers which are pre-built and those are trained widely on everyone's data. Now when we are coming to solving the problem of the context, where we say the context window cannot be so large so the model hallucinates, which is also talked a lot about Google in its latest talks, where they were saying that they'll create a model that would be such small in size and its precision would be equal to that of ChatGPT's. But I don't know where to draw the line, because when we talk about RAG, we first go to some open source models and try to pick up their trained transformers and then train that transformer on our private data. But where's the limit? If we would have built the model from scratch, don't you think that model would perform really bad? And if we go on into RAG type of solutions, is it limiting us from creating AGI? Because at the end, what we need, we are just limited by the resources. But we also want that the model should be trained on every single piece of data.
You asked a very long question. Huh? Lot of pieces you are connecting. Transformer model, what is that? That's a blueprint to make your model, LLM models. अब रैग की जो बात कर रहे हो ना, hallucination क्या बोलते हैं, hallucinations बोलते हैं, क्या बोलते हैं, hallucinations, क्या उसके ऊपर ग्राउंडिंग की जाती है। ग्राउंडिंग के डिफरेंट टेक्निक है। पहला टेक्निक रैग है, सबसे इफेक्टिव टेक्निक है। दूसरा फाइन ट्यूनिंग भी है, तीसरा और भी है, बहुत सारे हैं, जैसे आप के टॉप और बाकी चीजें जो ऐड करते हो उसमें बहुत सारी चीजें हैं। देखो, मॉडल आप अगर अपना बना रहे हो तो आप उसको डेटा जो दोगे ना उसी पे आंसर करेगा, ठीक है। अलग से आपने अपना एक जीपीटी मॉडल, जेमिनी मॉडल बना दिया, जेमिनी डेमो करके, कोई भी नाम दे दो, आपने अपना बनाया, आपने उसको डेटा दिया है सिर्फ 1 TB का, और वो 1 TB का डेटा क्या है, मान लो इस कंपनी की इंफॉर्मेशन है, तो आप जब उससे क्वेश्चन पूछोगे तो वो उसी कंपनी का ही डेटा बता पाएगा। आप उसको अगर किसी कोई बाहर की इंफॉर्मेशन पूछेगा वो नहीं बता पाएगा, क्योंकि वो आपका खुद का मॉडल है, आपने उसको ट्रेन किया है यूजिंग ट्रांसफॉर्मर, यूजिंग न्यूरल नेटवर्क, जो भी उसका ब्लूप्रिंट है, ठीक है। रैग जो है, रैग इसीलिए पिक्चर में आता है, रैग काम करता है जो LLM मॉडल, जैसे ये जेमिनी है, जो बड़े-बड़े मॉडल्स हैं जिनके पास पब्लिक डेटा सेट है, पूरे इंटरनेट की इंफॉर्मेशन है, वहां पे रैग काम आता है, ठीक है। या आपको कोई और डेटा फीड कराना है उसमें बाहर से। आई होप इट्स क्लियर।
Quite clear, but actually the point was just that I was trying to measure the intelligence ratio of the models, because generally we go with trying to train the model and all of the data to gain that particular intelligence, but on RAG it kind of limits the use case, because then you are just working on your context, right? Because ChatGPT also has a context window. You could give prompts to ChatGPT and now it will that particular chat will work on your context window. So what is the point of this is what I currently understand is just
What is the problem? Like, what do you want to solve?
just the problem is just that trying to measure intelligence of the AI models. So does RAG improve intelligence of a model
No.
or just
No.
the context?
RAG never improve the intelligence or the capability of the LLM model. RAG is just to feed your external knowledge to the LLM models. Right, that's it. RAG has nothing to do with the improving the performance, optimizing, no, कोई कनेक्शन नहीं है।
Thank you.
चलो अब थोड़ा आगे बढ़ते हैं, वर्कशॉप भी करना है, ठीक है। तो सबसे पहले आप इस QR कोड को स्कैन कर लें, ये मेरी GitHub रिपोजिटरी है, you can find it with the Anup issue, or maybe you can just scan the code, scan this QR code and open this GitHub repository. Once you are done, just let me know. Open, right? There is a readme, I mean, there is instructions, right? Just we will come back to this later. But before this, everyone has done this. Sorry.
Wi-Fi.
Oh, Wi-Fi is, I think, if you go, there is a Courage guest करके होगा, उसको आप क्रिएट कर लो, फ्री वो पासवर्डलेस है। डन, कर लिया, स्कैन कर लिया, लैपटॉप ही नहीं है, हाँ आंखों से स्कैन कर ओके, कर लिया सबने। चलो, ये करने से पहले पहले तो GCP क्रेडिट्स जिसको चाहिए, कुछ $5 का क्रेडिट्स है, आपके गूगल अकाउंट में रिडीम कर लो उसको। ये क्या हो गया, हाँ, इस QR कोड को स्कैन कर लो, या ये URL तो दिख नहीं पाएगा, बस QR कोड को स्कैन कर लो, और इसमें क्रेडिट है जिसको आप रिडीम कर सकते हो GCP प्लेटफॉर्म पे। ओके, हो जाए तो बताना। Done? I do this. इसके बाद क्या करना है? हो गया आपका स्कैन हो गया? अगर वहां से नहीं हो रहा ना तो आप आगे आगे कर सकते हो। हाँ हो जाएगा, उसमें हो जाएगा। अगर आप एग्जिस्टिंग अकाउंट है तो उससे कर लो, नहीं तो आप न्यू प्रोजेक्ट बना सकते हो। देखो, क्लाउड कंसोल लॉगिन कर लिया आपने सबने, ठीक है। आपके पास एक ऑलरेडी प्रोजेक्ट होगा, अगर जो पहले इसे यूज कर रहे हैं उनके पास होगा, ठीक है। अगर नहीं है तो इस जस्ट लिंक को क्लिक करो, ये अपने आप बना देगा। लेट मी नो इफ यू आर डन। कैन आई गो अहेड? ओके, सो अभी आपको ये साइन इन आ रहा है, साइन इन विद गूगल, ये लिंक क्लिक करने के बाद, ठीक है, ये अपने आप गूगल लॉगिन यूज कर लो, जो भी आपका पर्सनल अकाउंट है, और यहाँ पे देखो एक ऑप्शन आएगा, क्लिक हियर टू एक्सेस योर क्रेडिट्स, ठीक है, जो भी आपका अकाउंट है, यहाँ पे एक ऑप्शन है, इसको आप क्लिक कर लो। अगर आपके पास फ्री क्रेडिट्स पड़े हुए हैं ना, $300 जो रहते हैं, आप वो भी यूज कर सकते हो, आपकी मर्जी, ठीक है, जैसे भी आप लोगों को ठीक लगेगा, ठीक है। यहाँ पे GCP क्रेडिट एप्लीकेशन में फर्स्ट नेम, लास्ट नेम एंड देन एक्सेप्ट एंड कंटिन्यू। Right, done. This part is done. Here, this side, done. That side, or done. Okay. Now you can create the project, or you can simply claim the credits. It's up to you. If you have the existing project, you can go with the existing project. No issue. Now, then you create a project from here, and this is the project name. And then finally you go to the billing section. If you are creating the new project, you need to attach the billing account to the to your project. And credit sitting. Shall we start?
How to attach it?
Which?
How to attach new credits to the main project?
Have you followed this one? This link? It will. I'll help you out. This will reduce
Sir, how to attach? Because I have
your project. When you go to the project. This credit are applicable to all the projects, sir. Don't worry. Whatever projects existing new doesn't matter. Can we go ahead? हाथ खड़े कर दो।
yeah.
पक्का चले? चलो। अभी आते हैं मेरी पहली वाली स्लाइड्स पे। तो सबके पास GitHub रिपोजिटरी ओपन है सबके स्क्रीन पे, राइट? तो ये एक लैब का एक आर्किटेक्चर बताता हूँ, ये हम करने वाले हैं। फुली ऑटोमेटेड है, कुछ नहीं करना है, बस 2-3 प्लेस होल्डर है, वहां पे वेरिएबल्स चेंज करने हैं एंड वोला। सो in this lab we will use Terraform to deploy this entire architecture. We will use the Google Cloud Platform. We will create the data store, key component, structure and unstructured key component, which is a structure and unstructured knowledge base. Now data store is a service offering from GCP which will automate this entire rack system. Data store को आप मान लो कि एक rack component है of Google Cloud Platform for simplicity. Vortex सर्च क्या है? एक तरीके का आपका AI एप्लीकेशन है। 2 कंपोनेंट है, अगर आप यहाँ देखोगे मेरे स्क्रीन पे, मैं इसमें दिखाता हूँ बड़े में। अगर आप यहाँ देखोगे, मैं एज ए डेवलपर, लाइक यू पीपल आर द डेवलपर्स, यू विल यूज द Terraform and then you will deploy this entire architecture. Okay, you will deploy this entire architecture into the Google Cloud. This is the first step. First step is we'll use the Terraform, deploy the architecture. What we will create? We will create the AI application. We'll create the data store, and then you see this GCS bucket. We are ingesting our enterprise data onto the data store, and see there is a indexing. Indexing is nothing. It's called like very simple way, right? We are embedding our data. I have stated this term many times. Embedding. Remember this word embedding vector. Similar. We are embedding our personal data to the data store, right? And this AI application. Now this AI application is aware of your private data. Then we will load the data. How do we load the data? Using the script from the GCS. We use the script which will download the data from the GCS and upload it into the data store. Third step is we will set the prompt. We'll test it. Only 3 steps. Very simple.
The TCS is that somewhat like S3 or R2.
Exactly. S3 bucket. Google में इसको GCS बोला जाता है.
And why and what Silcom and Telcom and why we are using it, I can't understand.
डेमो के लिए हमें कहीं से तो डेटा उठा के डालना है ना. एंटरप्राइज में तो आप एप्लीकेशन से डाटा उठा लो, डेटाबेस से उठा लो, कहीं से उठा लो, वेबसाइट से उठा लो.
What is the use of telephone? कल के मेरे को नहीं समझ में आया टेलीफॉर्म का यूज और क्या काम.
यूज ऑफ व्हाट?
टेलीफॉर्म.
टेराफॉर्म.
Sorry. Terraform. Sorry.
देखो टेराफॉर्म कितने लोगों को पता है यहाँ पे टेराफॉर्म? टेराफॉर्म कुछ नहीं है. आप गूगल क्लाउड में जाते हो, मैन्युअली क्रिएट करते हो ना वीएम, तो वो मैनुअल हट गया. आप इंफ्रास्ट्रक्चर एज ए कोड है, आप कोड लिखो, वही वीएम आप कोड बना के दे देगा. तो टेराफॉर्म मान लो एक तरीके का पाइथन डेवलपर प्रोग्रामिंग लैंग्वेज है इंफ्रा वालों के लिए.
YAML फाइल वगैरह लिखते हैं.
ये हैशिकॉक लैंग्वेज बोलते हैं इसको, एससीएल लैंग्वेज. आप मान के चलो कि ये एक तरह की प्रोग्रामिंग है. इसको हम कोडिंग करके अपने रिसोर्स डिप्लॉय बना सकते हैं, इंफ्रा बना सकते हैं. पहले तो VMware पे होता था ना, आप लोग क्लिक करते थे, मैनुअल जाते थे, बहुत लंबा चौड़ा काम होता था. अब सारा इंफ्रास्ट्रक्चर एज ए कोड है. इट्स ऑटोमेशन. Infrastructure as a code, right? You want to automate your infrastructure. How do you do that? You go for Plumini. I think Plumini is also one of the tool. Ansible is a tool not for infra, but again for application configuration. Terraform is a very popular, infrastructure as a code, right?
This is related to OpenTofu, right?
OpenTofu is the second version of the Terraform. Terraform is now.
That's a different purpose for.
OpenTofu is a open source.
This is also open source. The CLI way, open source. Yeah, we have the enterprise again. आर्किटेक्चर में कोई प्रॉब्लम तो नहीं है, किसी को कोई डाउट तो नहीं है? कुछ भी डाउट हो प्लीज रेज योर हैंड. ठीक है, और टेंशन ना लो, इसकी वीडियो मेरी YouTube पे है, कैसे मैंने परफॉर्म किया है. कभी भी जाओ, इसके बाद भी आप कर सकते हो. ठीक है, टेंशन मत लेना. थैंक्स अगेन. मैंने QR कोड डाल दिया है, कोई अगर भूल गया हो पहले तो कनेक्ट कर लेना. ठीक है, मैं कनेक्ट इसलिए बोलता हूँ कि कई बार स्पेशली स्टूडेंट्स और जो न्यू कमर्स हैं इस इंडस्ट्रीज में, उनको मेंटरशिप अच्छी नहीं मिलती है. यू कैन रीच आउट टू मी. यू कैन रीच आउट टू मी फॉर एनीथिंग, वेदर यू आर बिल्डिंग ए प्रोजेक्ट, वेदर यू नीड माय हेल्प टू कंट्रीब्यूट टू योर प्रोजेक्ट. आई विल डेफिनेटली हेल्प यू इफ आई हैव टाइम. स्टूडेंट्स को कुछ भी मेंटरशिप चाहिए, कुछ सजेशन चाहिए, यू कैन ऑलवेज कनेक्ट टू मी. आई एम मोर देन हैप्पी टू हेल्प यू. चलो अभी एक काम करते हैं. मैं ये लैब नहीं करने वाला, बट आप लोग परफॉर्म करोगे. ये जो रिपोजिटरी है, इस पे आ जाओ सारे लोग. गूगल क्लाउड कंसोल खोल लो, और पहला जो स्टेप है, हम ऑप्शन 1 लेंगे. पहले टेराफॉर्म CLI वे से जाएंगे. यहाँ पे मैंने रैक की कुछ डेफिनेशन डाल रखी है, प्री रिक्वेस्ट डाल रखा है कि ये गूगल प्रोजेक्ट होना चाहिए विद बिलिंग इनेबल्ड. IAM रोज ऑब्वियसली अगर आप अपना अकाउंट यूज कर रहे हो तो आप ओनर रोज तो होगी आपके पास, और बेसिक नॉलेज ऑफ गूगल क्लाउड प्लेटफॉर्म एंड टेराफॉर्म. अभी पहला काम आपने ये करना है. क्लाउड शेल दिख रहा है आपको राइट साइड में, मैं दिखा देता हूँ. मेरा ये प्रोजेक्ट है रैक डेमो. यहाँ पे ये दिख रहा है आपको, एक्टिवेट क्लाउड शेल. इसको क्लिक कर लो. ऑथराइज. इसका जूम कहाँ से होता है?
Right side, open in your window. Right side, go right.
दिख रहा है, स्क्रीन विजिबल है? ओके, सबके लैपटॉप पे ये स्क्रीन आ चुकी है? गुड। अब गो, सॉरी क्या होगा? मैं बता देता हूँ। कंसोल लॉगिन कर लिया आपने? तो जल्दी करो, मैं आपको स्टाइप करूँ। यहाँ प्रोजेक्ट सेलेक्ट होगा, ठीक है? इसकी प्रोजेक्ट आईडी की कॉपी कर सकते हैं। चलो भाई, मैं भी कर लेता हूँ ये डेमो साथ के साथ, थोड़ा इजी रहेगा आपके लिए। ठीक है, अब पहला स्टेप है ये सेकंड स्टेप है क्लोन द रिपोजिटरी। ये कॉपी करो और क्लाउड शेल पे पेस्ट कर दो। मेरे पास ऑलरेडी एग्जिस्ट दिखा रहा है क्योंकि मेरे पास था ऑलरेडी, आपके केस में नहीं दिखाएगा। क्लोनिंग हो जाए, जस्ट रेज योर हैंड। चलो थर्ड स्टेप, ये पूरा कॉपी करो और इसको एज इट इज यहाँ पे पेस्ट कर दो। ये बेसिकली हम क्या कर रहे हैं, इनेबल सर्विस इनेबल कर रहे हैं कंप्यूट इंजन की, एआई प्लेटफॉर्म, स्टोरेज और डिस्कवरी इंजन क्या है आपका? वर्टेक्स एआई एप्लीकेशन है, ठीक है? ऐसे ही कुछ आउटपुट आपको भी स्क्रीन पे दिखेगा। गाइस किसी को भी कंफ्यूजन होगी ना, फ्रीली पूछ लेना, ठीक है? चलो नेक्स्ट पढ़ते हैं आगे। अब क्या है, हमें कंसोल में जाना है क्योंकि हमने एपीआई जो है ना वो एक्टिवेट कर दी है, तो हमको एक बार चीज वेरीफाई करनी पड़ेगी। जो सर्च है ना, यहाँ पे जस्ट टाइप करो एआई स्पेस एप्लीकेशन, ये दिख जाएगा यहाँ पे, ए एप्लीकेशन ऐसे दिख जाएगा। आपको शायद एक प्रॉम्प्ट आएगा, उस पर क्लिक करके एक्टिवेट कर देना, कंटिन्यू कर देना, ठीक है? डन? If you are done, then help each other. चलो अंकित, यू हेल्प हिम, ठीक है? बाकी का हो गया? चलो ठीक है। नेक्स्ट है सेट इन्वायरमेंट वेरिएबल। इसको वन बाय वन करना है, ठीक है? पहले ये आपको पहला ये कमांड कॉपी करना है, ठीक है? और क्लाउड शेल पे आना है। यहाँ पे जो ये है ना, योर जीसीपी प्रोजेक्ट आईडी, ये आपको यहाँ से मिल जाएगी। कंसोल पे जाओ और ये जो आईडी दिख रही है ना, इसको कॉपी कर लो, जो ठीक है, जो भी आप जिस भी प्रोजेक्ट में हो। मेरा वाला कॉपी मत कर लेना, और यहाँ पे आके इसको रिप्लेस कर दो। मेक श्योर देयर इज नो स्पेस। अब मेरे में स्पेस है, मैं इसको कम, ठीक है, कोट में रखना है इसको। प्रोजेक्ट आईडी से एक्सपोर्ट करना, एक बार हम वेरिएबल में डाल देंगे तो कमांड एग्जीक्यूट करना इजी है, ठीक है? दिस इज डन। नेक्स्ट इज we have to set the reason, which reason you want to deploy this component, right? I'm selecting US Central 1. US Central 1 is the kind of a data center somewhere in US. This is done. Third is G Cloud. Now we have to set the project. Guys, these three commands, how many done? How many of you here? This side, you are also done. I just raise your hand. Okay. तो आगे बढ़ते हैं, ठीक है? अभी हम क्या करेंगे? We have to authenticate to the Google Cloud. How do we do that? Just copy this fourth step, which is this fifth step. Authenticate with the Google Cloud. Come to Cloud Shell and paste it here. It will ask you, do you want to continue? Just say yes. this link, select the account, click continue, and then copy this this password, right? This is a small kind of a token that you need to copy it before you go ahead. Just copy this part. Hello. And then paste it here. Step 5 is done. How many of you? Step 5 done. That side, you can help each other, right? You can help your friends. Okay. Now we are moving to the 6th step. Now 6th step is very important here because if you look at the architecture, first, second, third, this is the first step. Start from here. Terraform की फाइल में जाना है और ये प्रोजेक्ट आईडी हमें रिप्लेस करना है. जो प्रोजेक्ट आईडी हमने अपने कुछ टाइम पहले रिप्लेस किया था. आपको क्या करना है, क्लाउड शेल में जाना है और यहाँ पे एक ऑप्शन है एडिटर का, ओपन एडिटर करके, जहाँ मेरा कर्सर है ना, इस पे क्लिक करना. ये कुछ विजुअल स्टूडियो काइंड ऑफ स्क्रीन ओपन हो जाएगा. ठीक है. अभी आप क्या करो, क्लाउड शेल में जाओ, वहां पे एक एडिटर का ऑप्शन होगा, ऊपर एक एडिटर का ऑप्शन, ऐसे पेंसिल सा आइकन होगा या फिर एडिटर लिखा भी होगा. ठीक, उस पर क्लिक कर लो. आपके पास एक तब एक काइंड ऑफ ए विजुअल स्टूडियो कोड काइंड ऑफ ए आ जाएगा आपके पास. और यहाँ पे कहाँ गया ये? No, don't need. I don't need to open a folder. Second. I don't know why it's taking a time. Just leave this page. Coming here. Connecting. ठीक है, मेरी स्क्रीन अभी लोड हो रही है, बट आई थिंक आपको दिख रहा है यहाँ पे कुछ, आपकी डायरेक्टरी कुछ दिख रही है ऐसे. यहाँ पे एक terraform.tf करके फाइल होगी, इसमें अपनी प्रोजेक्ट आईडी रिप्लेस कर दो. ये जो यहाँ पे प्रोजेक्ट आईडी है ना, जो भी आपने पहले कॉपी की थी, यहाँ पे इसको अपडेट कर दो. आई डोंट नो व्हाई इट्स नॉट लोडिंग. सॉरी, नहीं एक्चुअली मैं उस पे जाऊंगा तो रेप्लिकेट नहीं हो पाएगा ना, प्रॉब्लम ये है. ये पता नहीं क्यों ऐसे दिखा रहा है. जस्ट रिफ्रेश दिस पेज. अच्छा, आपका हो गया टेराफॉर्म? आपने कर लिया टेराफॉर्म वाले फाइल में रिप्लेस कर दिया प्रोजेक्ट आईडी. ठीक है गाइस, नेक्स्ट साइड डन ना. ठीक है, मैं I'll move forward. Let me see one more time. How much time we have, by the way? How much time we have? Okay, 15 मिनट में कर दूंगा. ठीक है, ठीक है. आप अगर आपने प्रोजेक्ट आईडी अपडेट कर दिया है, ठीक है, तो नेक्स्ट स्टेप है आपका टेराफॉर्म इनिट, टेराफॉर्म प्लान, टेराफॉर्म अप्लाई. इसको वन बाय वन रन करो. ठीक है, टर्मिनल में जाओ. I don't know what the hell is going on. चलो मैं एक काम करता हूँ, मैं यहां से अपडेट कर लेता हूँ, ठीक है? यहां से भी कर सकते हो आप। ये प्रोजेक्ट आईडी दिख रही है ना, यहाँ पे आप अपडेट कर दो, ऐसे भी कर सकते हो बीम का यूज करके, ठीक है? नो इश्यू। सॉरी, स्टोरेज क्लाउड कहाँ से आ गया?
क्लाउड यूज कर सकते हैं, वो ज्यादा फास्ट है।
कॉरेज क्लाउड, तो ये सारी फंक्शनलिटी कहाँ से लाऊंगा मैं? ये डेटा स्टोर और ये, हाँ क्लाउड है, गुड। अब ये काम करते हैं, ये सबने कर लिया। अब जो टेराफॉर्म इनिट प्लान और ये रन करते हैं। गाइस जस्ट फॉलो दिस, फॉलो अलोंग। टेराफॉर्म इनिट, माय फर्स्ट कमांड। You'll also see exactly this response. Done. Then plan. You see this output? How many of you see this output? No? आपका हो गया? अकेले ही हो आप, छाए हुए हो, और किसी का नहीं हुआ? Done? Just help each other. चलो अभी मैं थर्ड कमांड रन कर रहा हूं, वो है टेराफॉर्म अप्लाई ऑटो अप्रूव। ऑटो अप्रूव से क्या होगा, आपको अप्रूवल के लिए वो दोबारा नहीं मांगेगा, ठीक है? ये मेरा इंफ्रा क्रिएट कर रहा है, ठीक है? आपको मैन्युअली कंसोल में जाके क्रिएट करने की जरूरत नहीं है, ये मैन्युअली, ये ऑटोमेटिकली। देखो अभी यहाँ पे कोई ऐप नहीं दिख रहा, कोई डेटा स्टोर। Some issues.
I think that data storage already created. I think.
No, it's not here.
Same ID, creating with same ID. You need to change the ID, change the name of data store.
I'll change this one.
Seeing it as being deleted.
Hmm?
So just change the ID, I think will work. Change the name of data store, number 3.
This is your data store ID. I'll make it 1. Okay, you can see that your data store and app search engine has been created. How many of you are done with this step? You're done? Okay. Can you help other people? Can you just maybe? How many of you are still waiting for on the step? You're stuck. Maybe you can help. Yeah, guys, please. थोड़ा सा वर्कशॉप है ये. आपको थोड़ा सा इंटरेक्टिव होना पड़ेगा. चलो मैं अभी इसको रिफ्रेश कर रहा हूं. आप देख सकते, you can see that I have this data store. The data store name is this is the app name test engine and this is the data store ID 1. तो ये आप ये सोच लो कि एक तरीके का AI एप्लीकेशन सर्च इंजन है और ये मेरा डेटा स्टोर है जहां पे मैं अपना प्राइवेट डेटा फीड करूंगा और उस पर रैक कैपेबिलिटी बिल्ड करूंगा. ठीक है, डेटा स्टोर अपने आप में एक रैक सिस्टम है. नाउ हाउ डू यू फीड द डेटा? उसके लिए आप क्या करो, फिर से अपने कोड पे जाओ. इसमें ये स्टेप आएगा एक अपलोड द लोड डेटा. इसमें भी एक प्रोजेक्ट आईडी है, मैं दिखा देता हूं यहाँ पे. ठीक है, इसमें ये जो फाइल है load data.py करके फाइल होगी, पाइथन फाइल है. इसमें एक प्रोजेक्ट आईडी है, यहाँ पे अपना प्रोजेक्ट आईडी आप रिप्लेस कर देना, ये पार्ट है लास्ट में प्रोजेक्ट आईडी, यहाँ पे भी प्रोजेक्ट आईडी रिप्लेस करना है, कुछ नहीं करना है, हर स्टेप में बस आपको प्रोजेक्ट आईडी रिप्लेस करना है और कुछ खासा है नहीं। इसमें डेटा देखो यहाँ से आ रहा है, पब्लिक सोर्स है, दिस इज ए काइंड ऑफ ए बकेट क्लाउड सैंपल, यहाँ से हम डेटा फीड कर रहे हैं, कुछ 80 पीडीएफ फाइल्स हैं जो हम डेटा स्टोर पर देंगे, ठीक है। अब इसको मैं रन करता हूँ, सिंस मेरा यहाँ पे डेटा स्टोर आईडी थोड़ा चेंज हुआ था बिकॉज ऑफ, मुझे यहाँ पे चेंज करना पड़ेगा, आप लोगों के लिए सेम है। I'm running this script. Now what this script will do, this script will starting to load the data into data store, ठीक है, प्राइवेट डेटा आपका स्टोर हो रहा है वहां पे, this might take 5-10 minutes, I don't know, might take 5 to 10 minutes at least. So if I show you here, if I click on this data store, just notice that you will notice that the last document, the document ingestion import is in progress. You see this green icon? So the data is coming from the public bucket and importing into that data store, and this is the progress to take, right? Depending on your how many number of files you are feeding to the this one. You're done with this step. Okay. Okay. I think
जो पाइथन मॉड्यूल है ना उसका इंस्टॉलेशन नहीं है,
नहीं पर क्लाउड शेल में रहता है,
नहीं
इंस्टॉल में
then pip install python,
करना पड़ता है, मैंने किया,
अच्छा आपने कर लिया, ओके
करना पड़ेगा।
ओके ओके, नो वरीज, देखो कोई प्रॉब्लम नहीं है, अगर वर्कशॉप नहीं हो पा रहा है डोंट वरी, मेरे पास एक वीडियो है, सेम फॉलो कर लेना, और मैं इसका आउटपुट दिखा देता हूँ वीडियो में कैसे इसका आउटपुट है। तो अभी हमने कहां तक किया था ये, हाँ ये अभी हम टीएफ वार्स पे है, तो चलो यहीं से हम प्ले करते हैं। तो ये अभी मैं ये टीएफ वार्स वाली पे है जहां पे मैंने प्रोजेक्ट आईडी चेंज किया था, ठीक है, आप देख लो यहाँ पे टाइम टू इंजेस्ट द डेटा फ्रॉम जीसीएस। राइट नाउ अब देखो कंसोल पे कुछ भी नहीं है, क्लाउड स्टोरेज आप यहाँ से भी मैन्युअली भी कर सकते हो, बट हम टेराफॉर्म के थ्रू करेंगे। नाउ वी हैव टू अपलोड द डेटा, just change the project ID, just 5 minutes more. Now see, this script is basically loading the data. I have skipped this in the video, so you will not see the time. Generally, it took 10 to 15 minutes. So now you can see here, the completed loading data into the data store. So all the data has been loaded. Now you go back to the data store here, and you will see the status is green now. Means all this document, you see this, all this document. This document contains the Google Cloud information. I mean, basically the information of the Google, their revenues and CEO details and all those things. So see, this one of the indexing has been created, and this particular file has almost 12 pages. It has been chunked to 12 pages. All this data has been embedded into the data store. So you can see the indexing part here. You see here index. You see this index? It means embedding. Embedding has been done automatically by the data store. Now we test this application, whether this embedding is working, this RAG is working or not. So we have again one more file called query.py. See, this is done. Now we have to test the application. See, this is a query.py file. Just open this file and change the project ID again. Pretty straightforward, right? ज़्यादा कॉम्प्लिकेटेड नहीं है. हाँ, यहाँ थोड़ा सा प्रॉब्लम इसलिए आ रही है कि टाइम कम है और कई बार क्या होता है कि पैराफॉर्म बहुत लोगों को नहीं भी पता, तो आप घर जाके आराम से करना है इस वर्कशॉप को. Now I'm running this Python this query file, and there is already a query inbuilt. You can see this query. Who is the CEO of Google? What is the total revenue of Google? This is the query I'm sending to my data store, right? Let's see. So this is the response. You'll see here. You see the response of this application, and the answer is Larry Page is the CEO of Google, because this document is very old. That's why it is picking from that document. Right now the CEO is Sundar Pichai. We know that. Larry Page बहुत पहले था. क्योंकि डॉक्यूमेंट हमने पुराना दिया है ना, तो इससे क्या प्रूफ होता है कि जो LLM है ना, जो हमारा एप्लीकेशन है, वो डेटा कहाँ से निकाल रहा है? प्राइवेट डेटा निकाल रहा है. ठीक है. गूगल रेवेन्यू फर्स्ट क्वार्टर दिस इज दिस. ठीक है. ये जो हमने दिया, जो हमने फीड किया, इसको उसी पे आपको आंसर करना है. राइट. नाउ लेट्स मूव हेड. इसको थोड़ा सा स्किप करता हूं. और भी क्वेरीज, सैंपल क्वेरीज हैं, यू कैन जस्ट गो एंड अपडेट इट. बट इसमें मैं एक चीज आपको दिखाता हूं कि आप इसमें यू कैन नॉट जस्ट यूज द क्लाइंट लाइब्रेरीज, बट यू कैन आल्सो यूज द GUI इंटरफेस. आप कंसोल में जाओ. ये कंसोल है. ठीक है. यहाँ पे प्रीव्यू मेथड होगा. यहाँ पे मैं आपको दोबारा दिखाता हूँ. इसमें एक छोटी सी चीज है. मैंने एक सैंपल क्वेरी यहाँ से कुछ भी कॉपी कर लिया है यहाँ से. ठीक है. और देन आई गो टू द एप्लीकेशन. देयर इज समथिंग कॉल्ड प्रीव्यू. यहाँ पे भी आप यूज कर सकते हो. यहाँ पे भी आप प्रॉम्प्ट सेंड कर सकते हो. एंड यू कैन सी दैट दिस इज द प्रूफ दैट द डेटा इज कमिंग फ्रॉम दिस सोर्स. ये हमारा सोर्स है storage.cloud, क्योंकि डेटा हमने यहीं से फीड किया है. इंटरनेट से नहीं ला रहा है डेटा, आपके प्राइवेट डेटा से ला रहा है. ठीक है. तो आप you can also use this UI based application, right? So this is a mobile way. If you want to use like a mobile way, so you can just put your query and get the response. And last but not the least, once your testing is done, you have to destroy this infrastructure. Otherwise, it will incur your cost, right? So Terraform destroy auto group will destroy the entire infrastructure. All right, I think I'm done. Guys, वर्कशॉप किसका हुआ? एक ही बंदे का हुआ है. एक बंदे को अवार्ड मिलेगा. और किसका हुआ है? ये अवार्ड के चक्कर में हाथ खड़े किए तुमने. मैं पहले क्यों नहीं हाथ खड़ा किया? अच्छा, और किसका मिल जाएगा अवार्ड? और किसका हुआ है? हाँ, वो 10 मिनट लेगा. आगे का करते रहना. आपका चल रहा है? गाइस, प्रैक्टिस जरूर करना प्लीज. $5 जो है उसको कंज्यूम कर लेना. ठीक है. ठीक है. मुझे भी आगे बता रहा है कि हाँ बंदों ने किया है, सबने वर्कशॉप किया है. हाँ जी.
In case if you want to make sure, like, if my personal enterprise data has some information, right? I've asked it. Now, there are sometimes when someone is asking something out of my data store, and I want to make sure like it should reply. It should go to outside of my environment. It should go and search and give me a generic. I'm not saying. So can we integrate that?
Yes. Yes. Agent space, you can go with the agent space. When you create an app engine, there are multiple options. Custom search, media search. Then agent space is not available right now because you have to get the license. How many of you are aware of agent space? Just you only, yeah? Yes, of course. Agent space has lots of character. बाद में बात करेंगे. Agent space का जो नेटवर्क है वो बहुत बड़ा है. आप Salesforce से कनेक्ट कर लो, Slack से कनेक्ट कर लो, टीम से कर लो, जो भी आपकी एप्लीकेशन है उससे कनेक्ट कर लो. साथ में आपका इंटरनेट भी आप अवेलेबल है. आपको बस एक क्लिक करना है कि डेटा आपको इंटरनेट से चाहिए या आपके पर्टिकुलर Slack से चाहिए, कहां से चाहिए. ठीक है. That's all guys. I think we have more speakers in the line, so I'll not take much time. So that's all. Thank you for your time. और मुझे झेलने के लिए भी thank you. Thank you.
can move ahead with the next session, please.
Hello guys. It's 12:30. Okay, I think we had a very nice session with Summit, sorry. About the coding and everything. So basically, my background is different, little bit. So I am heading cybersecurity for Coverage, around almost 2 decades of experience in terms of the overall infrastructure and the engineering background and the cybersecurity, a lot many more. Okay, so and the previous session was very, I believe, very interesting, and you enjoyed the coding and everything, and we are like to make this session very interactive. Okay, so we are not going to give many lectures out here. Okay, so I'll run through some slides, but it is related to something. That's this small brief of mine. And this journey actually started year back, and I work with various organizations like IBM, Prophetic Knowledge, Index. Through that journey, I found one guy, and he's very shy and very interactive and proactive, but in the background, he was a very strong resource. And that he engaged with me, and we worked together to a certain level. Then he moved away from that company to another company. But that person is with me today. His name is Nitin Gulati. So he's here. He's the outside speaker, and I welcome Nitin come on the stage to join me on to make this a more interactive session. Yeah, please.
Thank you so much, Jay.
You can introduce yourself.
Yes. So I'm Nitin Gulati. I have experience of more than 2 decades. Okay, I started my journey with Renvexi, which is nowadays called as Sun Pharma. Okay, and then moved to the FMCG company, which is Perfective and Nale, wherein I worked with Jayanta very closely. And then I started with eGalisa. It's long time back. I mean, when my son was almost like 6 months old. Now he is going to college this year and will be joining computer engineering actually. So it's been like 18 years I've been associated with the eGalisa. So I'm working here as an associate vice president over there, and I've been managing cloud operations. I've been managing identity and access management, infra security, Microsoft, entire Microsoft stack, which is I'm managing. And we have multi-cloud over there, which is like Microsoft Azure, we have GCP, we have AWS as well. And we have recently started private cloud as well, which is on Nutanix. So that is what my journey is. And eGalisa is a research-based data analytics company, which is like more than 25 years old company. We have offices in Gurgaon, we have offices in Chile, which is in Southern America, and we have offices in China as well, which is in Shanghai, and in Europe, it is in Romania. So that is where I'm coming from. And we are coming from the days when, we used to have a pen drive. Now you guys are watching the videos and everything.
Yeah,
So we are very old timers, but good to see you, all the young blood who are working really, very, very hard. I've seen that. Thank you.
Yeah. So actually, what needs to be talked about? So we thought something little bit different because our background is purely of the security. Because we need to embed this security into your coding, correct? So you love coding every time, correct? So, but we skip something behind the scene. So without these skills, today's very competitive market, you cannot exist without that because of the dynamically changing every day, every now and then, correct? So it's just previous event, you have done a lot of coding and everything. You have some known errors, it's not working perfectly. So drive that thing. So I have particularly selected one topic called the runtime security. Okay, it's a I believe I don't know if anybody heard about it. Anyone can tell us runtime security? You are here, yes.
Yeah, sometimes what happens when you deploy a kind of application and it is running, because we have already passed lot of secrets just to make sure it is working. It is in the memory of your environment. Someone can get into it and check that part, and they can utilize those secrets or other information that is at the runtime in your service. That is one thing I understand. Apart from that, you have to secure in such a way like in case if that is running, at the time of deployment, we have to make sure it is not exposed to someone who can get that. Only the I can say the authorized partners or that person can get into it. That's one thing.
Yeah.
More I'm looking for.
Anybody else? Okay. So, give me a moment. Let me connect this laptop. At least I can go through a few of the slides. Is anybody there?
And by the time the Genpact starts.
Yeah, please.
How strongly you follow the password actually? Whatever identity.
Yes.
Do you follow the password like, or do you just type in somewhere and just do something? Anybody? Or I mean, or is it like password keeping 1, 2, 3, 4, 5, 6 something like that? I mean, if anybody can speak out about it.
इसको रिकॉर्ड भी करना
No?
है इस पे लाइव
Yeah, tell me.
अब पीपीटी कैसे शेयर करने वाले मेरे वाले लैपटॉप ठीक है मैं अपने वाला देखूं
Separate?
Document.
Separate document?
Yeah.
Okay, wherein you save the passwords?
Yes.
And is the document also password protected or is it open?
It's protected.
It is password protected?
Yes.
Okay, and do you keep the strong password?
Yes.
Okay, then you are in actually. So you are protected actually to a certain extent. So that is the basic fundamental nowadays. You need to at least honor whatever the password you do, and also please do keep on changing the password also. That is very much essential. Right?
रिकॉर्ड हो जाएगा रिकॉर्ड भी करना है तो इस पे पीपीटी है ऑलरेडी ये करना है तो कास्ट कर देता हूं इसको रिकॉर्ड
Yeah, before connecting to this slides, so runtime security actually, before going to that slides, we need to think about in traditional way. We always believe that security is nothing but security is sitting outside in your doorstep. It checks many things and also sees how things are going in a conference or in a performance, correct? So the same concept, we traditionally thought that we can protect many things, correct? So it's a pre-cloud era. We are only concentrating on the perimeter network, secure those perimeter network, like firewalls, IPS, IDS, then web in place, then coming down to a little bit further than EDR and the antivirus software we put in our laptop. So that model worked many long time and it's successfully even going through that market. But then during this pandemic, cloud came in between, but during the pandemic, everything has changed. So we need to think in the future perspective how we can get the business running as usual, correct? That is the motive. And cloud came into the picture, we moved the on-premise workloads to the cloud premises, then the complexity again goes up, so the pace of the security landscape always lags. So in perimeter security, we protect those things, but in the cloud environment, there is a lot of changes happening throughout these years. So we only concentrated only few of the layers. It's nothing but a layer of defenses, how we can minimize the bursts inside your network, Okay, how we can stop exploitation of any data. We are all are working on data only. In the bottom line is data and how we can protect the various data, financial, medical data, or any insurance data. So that thought has strike that period of time, how we can protect this particular area. For example, I wanted to show something here. In traditional way, we have this data center, we have connectivity, we have a firewall, then our server farm, S farm, BO is a business launch officer. This is a traditional way we used to work and protecting the various applications, the SAP or the your financial data. This is traditional method we used to do. But we never concentrated on this piece where our entire landscape was running from the server farm, the app application, then the DB is always never be concentrated, but we are trying to protect only this particular area of difference. Okay, so runtime actually continuously dynamically changing your environment. In the cloud native environment, it's continuously changing. So where we need to protect these things, it's a very complex model, correct? So AI has already pitched, correct? So threats is becoming very eminent. It's obvious that we need to think about that way, how to protect those code changes during the life cycle. So you are experts in coding, but you lack something there where we usually miss that area to improvise that. So we need to bring some kind of mechanism. It's all about the mechanism of thought, because we have to embed these processes into the place. Tool everybody, because we also create different tools, correct, to protect the number of data type, number of accessibility. Lot of things is happening, but those itself might have some kind of a bar itself, or maybe vulnerabilities. There is a complexity arises when we like in the serverless, now technology comes to serverless functions, then your Kubernetes structure, then your microservices, APIs coming in such a way, it's very difficult to adjust those APIs, because you are calling a lot of for example, I can give you some kind of a supply chain attack. In the supply chain attack, you are dependent on the various suppliers, correct, to integrate various platforms. So to track those things is very difficult. So you need to put in such a way your mechanism that can be, that is called your CI/CD platform. So you do all the development and the adoption onwards, verify these whether they are correctly running in as expected or not. So we need to embed these security mechanisms into place to protect the entire. So we need to detect in the first level. So in the traditional way, that detection was the very complex and they always bypass many things. So it's very hard to, because in traditional, for example, static firewalls or the routers or the internet, they are relying on the policy-based kind of a approach. So it's very difficult to identify any vulnerabilities or any threat. So that is what this whole stack came into the picture. So from the beginning itself, it's a proactive nature to monitor each at every level. So you changes the code as per the requirement. When the code has been changed, you need to also verify these codes. So there is some mechanisms. I am going through that slides.
A very strong point which Jayanta actually brought up on the defense index. I'm not sure how many of you have actually seen data center as such. Is there anybody who has seen the data center? Of course, sir. Okay, where? Okay. So for rest of the people, I think it is very strongly recommended. You can watch a 6 minutes video which is on defense in depth from Google actually. You just type in, in the Google 6 minutes Google data center visit. So it will show you defense in depth, starting from physical layer to the internal parameter which Jayanta was talking about. So it's a 6 minutes video, very beautifully, I mean, scripted, crafted.
Yeah. So, what benefit we can get out of it? Because that area we need to focus on very rigorously and rapid manner, because rapidly changing environment is very difficult to track it. So it will give you more proactive in nature when you provide this real-time visibility. So we in Coreage also we have the visibility and observability. We are already working in to some extent, right? So we fed into the Grafana, correct? So you are using Grafana. That we are trying to prepare the baseline of that particular compute and the memory, the traffic between the pods and your utilization or optimization happening. So we need to during this journey you need to make some baseline. So you have to fix that baseline to some extent. Then top of it you need to monitor it, you need to visualize it. Whether is there any drastical change in this CPU consumption? So that could be a trigger point that we can see possibly there could be an exploitation is happening. So only observability is not enough. So you need to connect with some sort of a mechanism where you can see real data. You can say vulnerabilities into the screen, correct? So that can be triggered into the SIM solution. It is nowadays very popular because it's a proactive in nature. So for these sources has to be monitored, and that follows zero trust architecture. So it's now becoming a very hot topic, and people are, because cloud is all about the accessibility, correct? So you can access anything from without authentication. So he credited your $55, correct? You have the authentication. There's no way out. Until you don't have authentication, you cannot do it. So that authentication is very crucial. So that follows some kind of a mechanism that you can
Just
zero trust architecture, the principles are there. So
let me just try to add what Chintan actually said on this slide. Whatever you do on your laptops, which is provided by the organization, don't mix up with the personal stuff actually. Always, do the personal stuff on other system or your own mobile. Never ever actually mix up these two things. If you do this practice, believe me, approximately 60-70% work is done from the security standpoint.
Yeah.
Okay, so it will be very hard for any hacker to exfilter the data from your system. So please make a practice of don't get into any personal stuff on your official laptops. That is my recommendation, right? And on the zero trust, I will share some analogy actually into this. Say for example, if you are going out of your vacation for a few days, okay, or maybe outside, maybe with a family or maybe official trip, okay. So obviously you won't do something on the social networking, posting something, you are going somewhere. Why? You should not do that, because it is kind of a social engineering attack which can happen actually on your house. Everybody will get to know, okay, you are moving somewhere. So that is the practice I think you should follow. I mean, there could be insider threat as well. Even if you live in some apartment or somewhere, there could be insider threat as well. So in a similar way, in the digital world also, the zero trust is something like that only. Don't trust anything. I mean, just believe or follow the basic hygiene, encrypt the data, follow the TLS, do the HTTPS kind of a traffic. I'm sure you must be knowing about HTTPS, which is 443 if you publish it on the website. Never use HTTP actually, which is very vulnerable. And if you access something on the remote desktops, always change the default ports actually. So those all basic hygiene, I think if we follow, the most of the stuff, will not enter actually.
yeah, so the principle says that you need to have some kind of a standard mechanism to minimize the attack, correct? So you cannot protect everything 100%, correct? So you have to minimize the burst attack. So zero trust means that the least privilege in place is particularly designed for the identity and access management process. Because most of the service providers like Google, AWS, Azure, they provide these kind of services. So that has to be embedded into our core infrastructure. So because our product is also going out, correct? So we need to think that way. And these privileges, you should not believe anybody else. You don't trust anybody else. You have to verify them. Whether insider, outsider, doesn't matter. Ultimate goal is to we need to protect his data in the form of many things. Correct? So you have to verify each and every time who are logging, who are not logging, how many times he has logged in, how many attempts have been made. So that needs to be keep tracking every now and then.
Just to add one more thing. I mean, in many organizations, there is something called NAC kind of a solution which is there. Meaning, if your system is not up to date, okay, you won't be able to connect to the office network actually. Unless until you get the things updated, you won't be connected. So there is a terminology which is called the NAC solution.
Yeah. So that possible level of tools.
That follows on the principle of zero trust.
Absolutely. And why so important? So because any product-oriented companies need to best possible services and product needs to go out in the market. Correct? When something go out in the market, it is very, very important to comply with the different regulations. Okay? Without that, you are nothing. Nothing is there. So now these challenges coming into each and every organization. The compliance, internal compliance, whatever you have built inside, and the external, the land of the law, that you need to follow. There is no, like, for example, in Saudi Arabia for the SAMA compliance. So this SAMA compliance built from the different compliance standards, PCI, GDPR, NIS 353. So based on that compliance has built, and you need to follow whenever you do some kind of a exchanges or monetary transactions happen inside that land in Saudi Arabia, you have to comply with that regulations. Suppose you want to do a business out here, there, you have to be compliant with each and every level, from the code level, from your DevOps level, from your stage level, that has to be certified. That there should not be any data, private data should not be embedded into your, or any card information should not be embedded into your product. Okay? That has to be followed, that guideline has to be followed. So to protecting that thing, that is why runtime security was the last resort to protect. So you have a lot of defense mechanisms in the outer world to protect, to minimize the exploit, but the runtime security is the last resort to protect it. So because of that, you need to comply all regulations. Wherever you do business, you need to do compliance. Okay, so these are the concepts built up to the security space. So we usually not in a cloud native environment. We have VM serverless, then you have a lot of microservices running here and there. And then next concept come up only how to you cannot protect everything in 100%, but at least you need to some mechanism to detect it. Correct? So you have a lot of open source tool than the paid tool, but the challenge is there in this market. Is hell lot of tools are there. Hell lot of tools. It's very difficult for a like Nitin also. We are just discussing about how we can select a best tool. So there is no concept of best tools. Okay, so there could be possibility of vulnerabilities inside that tool also. And for us, for decision makers, it's very difficult to judge which would be the best tool. So we talk about a lot of that. So we will come back to that slides of the number of tools we usually there's some industry standard tools are there. And you detect first to at least minimize your impact. Okay, then you need to prevent them, then quarantine them. There's a process that we need to follow because behind the scene you have a lot of tools mechanism nowadays available where you can it gives you more real time happening inside the network or inside your infrastructure because from the financial organizations like banking or the insurance organizations like the here in HDFC insurance or something like that, they keep on monitoring these layers continuously. So because is there some challenges is come in between, so we will talk about that. So Nitin has very good experience in this particular area where he came across these challenges and how he overcome these challenges for a ransomware attack. Okay, he will explain later on. And then that is the response and remediation. That is always with that mechanism, or you can say have very good governance and the process you need to have inside, because it's a continuous process. You cannot ignore it. Then the observability is nothing but your monitoring part. Okay, so I already talked about that. So you need to make a baseline, then you keep on looking into it. You need very expertise. You could be probably in future expertise on security, because security also rely on the coding, correct? Without coding, everything is nothing. The code level, you need to identify the various vulnerabilities. This is the way you need to do. So you need to, whether you are compliant or not, you need to check we are really compliant with the various standards, the PCI or the GDPR or NIST. That tool now it is all about automation, correct? So everything will come through the tool that my product is compliant. Yes, we are ready to go in the market. But you cannot be protected everywhere. But your products will go and do the marketing things. There are the supporting elements, nothing but these policies. You need to have a very robust policies in place because governance is another area where because we coders only believe every time we can go with them, we can just give the DevOps team, they will verify. But is there any mechanism? Is there any changes, drastic changes happening? Is there any process in place? Because you understand that the change is a very critical for a company, correct? If there is a major change, then it has to be tracked. So you need to follow these guidelines to policies changing and instrumentality. Few tools you can use it. We will come down to that. And behavioral baseline. So I just touched upon in the few minutes back. Anybody can talk about behavioral baseline? Do you have any idea what is behavioral baseline?
Behavior, or maybe the anomalies which is almost.
Is there any? Do you have any ideas? Can you speak a lot? Sorry, so let others to come forward. So you know to try. So you need to understand because these things will come in your everyday life going forward. When you will be doing a lot of coding and everything, it will come all definitely. Behavior baseline is nothing but a. For example, you can see how anomalies identified. We made a baseline. One user entered into that particular workspace, for example, for a Kubernetes cluster, okay, and his or her timing was different. For example, during the evening time, she always logged in on that particular cluster, okay. And all of a sudden, you will see during the noon time or the midnight, her authentication or the traffic has exponentially higher, which was not a good sign for it. So, what could be the reason? So, then there is a spike in your CPU consumptions. Okay, there is in terms of the baseline, you can see. There is a threshold to meet, so you go beyond that particular time and seeing these anomalies. So these baselines is called behavioral baselines. So if it goes beyond that threshold, then there is a possibility of some kind of anomalies. It could be threat, it could be anything. It could be any over-utilization of the memory workflow or something like that. Right? So
and just another example to anomaly could be like, say, for example, you have an identity called Amit or Sumit or anything, right? And all of a sudden, like if you're working from Gurgaon location, this tool what it might give you an alert. Say, for example, your identity suddenly got logged in with some example Bangalore. Okay, so this is kind of anomaly, right? You are sitting over here, and how come within the next 5 to 10 minutes your login is from Bangalore or somewhere, Chennai or somewhere? No? So that kind of anomaly alerts will actually highlight you and will trigger that something is going wrong with your identity, right? So as a remediation step, I think obviously then you need to immediately, log off or, change the password and everything.
Yes.
So that is what another example which I thought I would make.
Yeah. So these are the trade models, possible zero-day expert. Anybody can speak about zero-day expert. Anyone. Yes. These are the common terms in nowadays. Because coders know.
I mean, whatever Jayanta and me are actually telling, this could be actually boring for you, I
Yeah.
understand, because you are coming from the coding background. But believe me, if you have little bit of sense on this as well, so after certain interval of time, probably you will see, yes, if you know coding plus you know little bit of security, you will always have upper edge down to the line. Okay, so please try to be little focus over here. It will be obviously good actually.
So actually, when you keep on developing everything, correct? So you need to release your product in the market. So definitely there will be always can be protected everything. Because the product demands in the market it will be released. For example, Office 365. Right? They launch with bugs. It is obvious. It's nobody can give you the. It's all about the experience gained from the market. Then they put the patches accordingly, then again the new release comes, correct? So when there is no patches, so there is possibility of some kind of a bug inside your product, and that product can be vulnerable to the threat exploiter. They can come inside. This is the chronology actually. They can go to the privilege escalation, gaining your root or admin authentications. That means once he gets there, he can do anything. So he can change everything. He can change, he delete a one port where you are testing something. Basically, they target on the production number of times. So,
And by the way, what is the root username which you use? Anyone? Yeah, that is obviously the very bad practice actually. Just rename it actually. Okay. So never use the default root or admin or sudo or something like that, right? So
then
that
password will be admin 1 2 3
yeah. So never have that habit actually. Initially, maybe in the testing something you can follow that, but when you go into development or even the release, don't do that kind of mistake. It will cost humongous amount actually to the organization, believe me. So never ever do it.
Yeah, it's all about money.
Yeah, have some. I mean, we all should be a little bit of responsiveness we should have actually. Let us take care about whatever the resources we are using for the organization, and let us do it effectively. I mean, we know. I mean, we are doing wrong actually, right? When we log in, it is the convenience which we are going through, right? Just type in root, password is admin or blank, something like that. So I mean, trust me, it is not a good practice at all. So let us avoid this.
Yeah. So zero-day exploit means there's no patches available. There will possibility of crack that can explode inside. Then take advantage of previous escalations because it's related to this only. Then if he gets this root access, then he will again go to the lateral movement. Then he keep on adding his attack into the different areas. Okay, so maybe one tenant to another tenant, one port to another port. So wherever he finds something very interesting in the financial, he puts some kind of code, then he will be able to crack it, then he need to pay some amount, then he need to retrieve this. It's very, it's not a small amount, he asks a lot of, per $1,000 per.
In fact, it can go to $1 million as well, believe me. and what I was saying, I mean, on the 0 day, I mean, I'm not good in the coding, but I believe somewhere in the coding also, maybe you might be, feeding the password somewhere. If that is the case, never use, such kind of a behavior because that is what the 0 day exploitation is, associated with. I mean, most of the stuff which we start with the development, we know we are doing something wrong, and that will cost some time. So there are certain code, level practices we should obviously follow.
and now I guess it's now very popular now, supply chain attacks. So we relying on various other organizations, okay, connecting with API calls. It's very cumbersome for everyone, correct? So whether use API will go for to enhance our product or not. So they target in such a way these microservices from different organizations, and they try to exploit a lot of things. So it's a very, that is what risk assessment is regular basis is very important for an organization in many folds, correct? So because if you don't risk assess, you won't be able to justify to your organization whether you are really have that appetite to data loss, correct? So this supply chain is a very cumbersome. You cannot rely on it in every API. In the market, everybody said that yes, this API is also fine, but you need to verify that API. You need to scan this API, whether if they are meeting our expectation or not, before integrate into our product. So any questions? So we can throw some questions. We try to give you some answers also. I think it's very
During the
important.
last session, I mean, there were not many questions, actually, Sumit was facing those questions. Yeah.
Now we have the coding events also. Like some coding events.
I'm audible. So now we have the coding events too, which we used to like code something or make something. So where we have a .env file stored, like where we expose everything in the passwords everywhere. So like what will the security step to ensure like how we are securing our passwords and everything.
So you want to store that password in a such a way nobody can access that password. Correct?
Yes, the coding agents are we are using to build something. Like,
Correct.
Which is
So there are a lot of mechanisms out there in the market, a lot of tools available which protects the saved password, correct? So even accessing that password also you need to have authentication mechanism to code, correct? So that is the best way, because earlier what happened, we write down those password and put it in the envelope and put it into a safe locker of the head of IT. Okay, then only we get these license keys as well as the password and do the changes. Nowadays it's not happening like that. We need to have a kind of a encrypted, robust encryption mechanism. The tool itself to store those encrypted in the tool. To retrieve those passwords.
So there has to be strong authentication mechanism. Okay. In my organization, what we have done, I mean, I don't know how we access the emails over here, but what we have done in our organization, while we access the emails, it will, in every 12 hours, it will ask for a second factor authentication. Okay, which is nothing but a multi-factor authentication. So you need to do the authentication from the authenticator app actually. Okay, so one is the password, second will be the authenticator. So these are the multiple factors which we are actually adhering to actually. Yeah.
So in Google, so then I can tell you one example of securing the way what we did in our workshop. So we have used our identity. Like we have used logged in with our user, the Gmail ID you logged in. Okay. There is a method of service account as well. Maybe some of you know. So service account is basically an application login. We create the service account in Google IAM and then we use that and we authorize our identity to use that service account. So service account will do whatever we want to do. We will provide the roles and service account will do. We are just authorized to use the service account. So this is a way of the encrypting our password. Okay, and one more thing, there are multiple ways in Google to more secure it. There is one way like Burglar Identity Federation. There is a whole chapter I need to tell.
Yeah, it's a ocean actually.
Yeah.
I think it's
Maybe you know,
Vulnerability federation, where we don't generate the key, we just use the key. Okay?
Yeah, and just to add, I mean, at the enterprise level, I mean, there are, I don't know if you have heard about Active Directory or not over there, or Entra ID something. Okay, so there is a concept in Entra ID which is called a global admin. Most of you might be aware, or I'm not sure. Or in the traditional Active Directory, there is a concept called enterprise admin or domain admin. Okay, in our organization, there are no domain admins or no global admins. I will tell you the way, I mean, how we have exploited it. So it is the generic built-in accounts which we have renamed, okay, and nobody has a password on that. So what we do, we grant as a just-in-time kind of access. So there are two teams. One team has the initial 10 characters password, they log in, and the other teams come up and they type in the next 10, 12 characters of password. Then they get into it and then they get, give the access accordingly, and then they revoke it accordingly. So nobody has the access. So that is what I'm trying to emphasize on the importance of protecting the identities actually. Okay, so I mean if you take it very seriously, it will believe it will help you a lot actually in terms of that.
So a few best practices in the market. So you talked about each and every line already covered. Least privilege access. In the container services or in the Kubernetes services, least privilege means the minimum your accessibility is required. Correct? So because it's also bind with the process in the organizations that needs to be followed. So only the people who have that access, he should gain that access. That's it. That means in the earlier days, everybody had the admin password and the admin role, and many changes have happened. Nothing is because of the there is no process in place. So these privileges that help to minimize the impact from any eventualities. So this is best practices that already Nitin has explained. So in the market, we have some standard tools are there. RWAC is a concept, is nothing but OPA is a IAM. Many organizations having, like Google having own IAM solution. Then Azure has own IAM solutions and all this thing. Runtime behavior profiling, that I have already explained to you. These are the very robust tools in place where the Falco, Sysdig, Prisma is a new one. And these are the organizations, they have to identify the various vulnerabilities inside the code level that will help you to expose these at any kind of abnormalities inside your code or not. Okay, so it will give you can integrate a lot of things along with the same solution or the monitoring solutions to see the actual real life happening inside your this layer. Then continuous monitoring and logging is very, very important. And from the runtime security perspective, these are the mechanisms where you can telemetry. The problem is here in telemetry also you need to also see is there any kind of a man in the middle that for the telemetry also is a very robust things also that we can discuss later on also, but it's a very interesting subject where when you send the logs from your sources codes or the any Kubernetes cluster or from the any VMs or the storage or your network, that telemetry goes to a single repository where we keep the logs for correlation and the threat hunting. And during that process of the even you do encrypt, correct? For threat encryption is there, SSL encryption is there, but there is a possibility of cracking that particular pipe, correct? So they can have the telemetry and they can give you more false positive alert to your system. Everybody still working on that day and night to hunt down the false positive alerts. So there is a mechanism where we can stop these issues by putting this extended Barclay packet filtering. This is a mechanism you can use in the code level. Okay, so very interesting subject. So the mandatory access control MAC, where you have a lot of tools are there. Microsoft is there. These are the open sources tools where you can export. I think Nitin has very good experience on this part, so he can explain a little bit about the bank.
I mean, before that, I think we should also focus on the continuous monitoring, where I can
Yeah.
talk more, a little bit about that as well. In many of the organizations, whatever you do, believe me, all those are being monitored actually. Okay, whatever you do, okay, even if you send an email and then say, okay, I will delete it, should delete it. Okay, trust me, it is still there. Okay, there are ways actually it can be deleted as part of the legal compliance regulations. Okay, so never ever mess with any organization data at all. Make it as a practice, whatever the data is there, let it be on your system which is provided by organization. Never mess it because everything is being monitored, and trust me, there are many cases which I have seen, which I have witnessed, people are being fired. I mean, when they are being, monitored something intentionally or accidentally. So never ever mess with this kind of methodology. I mean, there are tools which are available, which are done behind the scenes. You might not be aware of it. We have implemented. Janta has also implemented, has gone through as part of the strategic planning. So we know there are many tools. So I think on the access part, I mean, we've already talked about. We should have a strong access methodology wherein whatever the rights are needed, we should grant only those rights. Let's say, for example, if you have, if you go through the IN, you will probably, have the maximum rights, there will be least rights. So those kinds of, practices we should follow. Okay, I need user access management kind of rights. Let me have that rule, not the extra rules.
Then supply chain protection, we already talked about how we can protect. There's some tools in the market where we can use it. These are the basic things, but the most importantly, that set of integration. So it is the practice that needs to be followed nowadays for each and every organization. Earlier, only DevOps was in the market. Okay, so we only then the ops team will verify everything, put some automations, but we forget about the security practices there. Due to this, we won't be able to get the right product into the market because we cannot see any vulnerabilities or bugs inside it. So there is a mechanism, or we can use various third-party tools. You can scan those tools because you need to embed that in a life cycle, that particular tool or process to find out the vulnerabilities and work with the development team and DevOps team to make it as the best possible tool or the product outside the market. So this process has to be embedded in your development lifecycle. Without that, your compliance will fail. No compliance will really to pass on. That means the customer won't come and use your product because each and every regulatory has their own robust or complex requirement. Some organization might not fulfill those requirements due to the over cost run. Correct. So that needs to be very, very carefully to put these things in practice to minimize the cost and the impact. So at least the product should have some kind of a.
I think you're talking about software development lifecycle, SDLC, right?
Yes.
Yeah.
So
Theoretically, it sounds very boring, but I think we should put this into practice as well as.
So there's the pen testing and the modeling, runtime threat modeling. These are the mechanism how we can is nothing but a hacker. So I believe most of your hackers are sitting out here, correct? It's all about the codes. They are on the codes, correct? So the intent is different. You are a very lovely people don't intend to go for that. Yeah, so your ethics says that no, I don't want to do such things. The non-ethical hacking is nothing but the same way practice, correct? The intent is different. So that tool is itself is a hacking tool, correct? So either you can use as a good sense or usually use a bad sense, correct? So a lot of tools are there, so that you can create a lot of people inside your organization how you can protect that particular threat from the outside. So These are the best practices we have covered. So if you have anything about this.
I think the shift left, which is there in this slide, actually, that
Yes.
it is nothing but, have a coding and design it such a way wherein you can secure it at the design level. Okay, rather than once it is produced or at the production, don't do that way. Don't do the security at the, starting level actually. Okay, because at any case, I mean, if you hear, okay, there are, fixes which is coming up, so that comes after the release. That is not a good practice. So, have security measures at the initial stage. So that is what shift left is, mentioning.
So any questions, guys? Anything? Yes, please. Here I want to say.
So I believe whenever we are going with the pen testing things. So whenever we go through pen testing, and to be honest, there are multiple scenarios, and we found multiple global agents available in the environment. The point is how to track that where it has been used. We know the logging, but still, out of that, sometimes what happens like, I'm just giving you one scenario what happened. There was a person, and he get into our environment, and he was sitting on the Kubernetes pods. And what he was doing, he was using our resources silently, without any giving any kind of things, or it is not raising any warning for us. Very small, to each pod it is going, and it is just utilizing the resource. But like it is a regular thing pen testing in our lab. But after 3 months, we get to know that that person was there from last week. Now our question is, in case what all the things he has checked out, how to get that one?
Okay, let me think about this. This is very new to me actually. So number one is, I mean, like Jayendra talked about difference in them. Number one is identity actually. There has to be some identity where he might be using or she might be using, right? First of all, the identity should be deleted. Okay. Second will be the connectivity access. That should also be disabled for that person if that is carrying a given connectivity. And another is on the Entra ID, there are ways we need to configure the alerts actually. It might not be configured. That is the reason it is not generating the logs actually. The logs are there into that, and it should be, the alert should be set to some email ID so that it can send an email alert to the target person or whoever the relevant person. And lastly, and the most important thing is reduce the global admin as much as you can.
That is enough.
And also apply the multi-factor authentication on all the global admin, whatever the case.
My question is that in case if I have to get press, what was happened at that time? What all the things he has checked out.
So I need to add there. This is called a runtime security in place. Okay. From the base level, you need to monitor everything. You need to track each and every from CI/CD lifecycle. You need to put things in place that you need to every code written into that particular sprint. You need to put security in place. Means you need to assess this whether you are writing the right code. The code is not giving you the right output. Is there any vulnerability is there? Okay, then put some kind of a code-based alert agent. It's for example, Falco. Okay, in the code level, they will analyze this. Okay, is there any drastic changes behavior? Now talk about that user coming into place. So you have the user has an authentication mechanism, correct? So every boss he move around here and there. There's kind of your mechanism in place where he should not access. Maybe he got the privileged access of that particular root admin. That's why he moving from one port to another or one tenant to another. Yeah, that will generate from the logs, correct? So you have to keep on monitoring each and every life cycle.
Yeah. And apart from this, there is another question is like, this is second scenario. So scenario is like there is a one application, and whenever someone access our application, there is a GRD generated, and we call it correlation. As soon as that happens, and before running the application, when application get up, so you have seen that sometimes developer what they have done like fetch the MongoDB credentials, and they listed that part in the logs system. And even if someone get into the logs, that person can get into the credentials. That's the one scenario, oldest one. My question is, how to like, because we figured it out after a long time that person has done this particular bad thing for us, and it is going to data log. Still, it was a controlled environment, but our point is it was passing earlier for a long time. Now, my point is how to get that scan because we are
Because you are doing a reactive approach, correct?
it already happened. My point.
Already happened, then you have reacted, correct? So that needs to be go back
Before that.
before that, correct? So you need to have some that mechanism in place to proactive approach. That is a runtime security is very, very important. That is the important thing that we are discussing right now.
Yeah.
So, like in traditional environment, we are all having some kind of a reactive approach. Something will happen then only because IPS signature what happened. Some sort of standard they use it in IPS signature, correct? So they cannot some correlation happen or some sophisticated attack. Now AI comes in. So these perimeter devices cannot hold those pressure from the outside, correct? So there is a, that is why runtime security is a very, very core to protect this last resort that we need to, once this is, nothing is there. So if runtime security is no more, or there is possibility of escalation route, then privileged access kind of a breach is there, then you are gone, correct? So that is what the main important, we need to focus on the runtime security only. There are a lot of methods are there to protect this.
And as said by Chandra, there is a runtime security. So there is a famous terminology which is going in the market nowadays, which is called the CNAPP actually. Okay, so I don't know what is the full form, Cloud Native Application Protection Platform, something is the full form of that. So that tool actually tests the misconfiguration which is happening usually to a larger extent. Okay, that will figure out, okay, you are doing something wrong with that. So
Yeah.
how are you able to fix this?
That is what the problem lies with the supply chain. We talk about, correct? So we have, because of the price factor or the some development factor, because it's also about cost, correct? So we always tend to lean towards the open source mechanism. So it's because it's available. So you can use it now and then, every time. So there is a possibility exploit this API coming into your environment, correct? So that is what risk assessment of the third party organizations or the API tools is very, very, it needs to bring into the practice inside the organization.
I mean, I can speak about my organization. We have like almost like 250 developers actually. Okay, and few of them does that kind of mistake, like putting the password and stuff. So that is where the CNAPP actually comes into handy. So we have a tool which is called the Cloud Guard from Checkpoint. I'm just naming it. So there are many other OEM as such at present also in the market which actually complements actually. But the bottom line is, I mean, grounded thing is, I mean, if you do follow the best practices, the CNAPP will or any other tool will complement all of that.
Okay, so we are almost done. I think how much time we have? 5 minutes? So this is quite boring, I know, but we need to understand why it's very, very important. Okay, so going forward, it will really help you out to embed these things into your coding. So case studies, we are not going to discuss everything. So he has a very good experience about one of the incident he faced. He can explain a little bit about it.
So in many organizations, in general, I'm speaking, there are cases the organization get ransomware attack. Okay, ransomware attack is a very serious actually term which we hear actually. Anybody knows, I mean, what is ransomware? Anybody? Any volunteer?
So if someone get into your environment, they will encrypt your files. They will encrypt your files or systems.
Yes.
And whenever you try to access, you will not get it. Even you have the access, they will remove your access. They will get their encrypted form. And whenever you say like I need to get this data, they will just pop up one message that if you pay this particular ransom, I will pay you encrypted key.
Correct.
And then you will.
Correct.
So that's how they get it.
Yeah, that is what the ransomware is. I mean, it actually encrypts entire server, whatever it is, including every hard disk and everything. And when you open it, it will have a notepad file, okay, which will have all the details. Okay, contact details, send an email and spend $1 million of money, and then we will, give you the key actually. Okay, so the basic fundamental is we should follow a practice where we should, follow the security updates practices. We should follow the password. We should do the multi-factor authentication. So all those stuff which actually Janta also showcased on the least privilege access, those are seriously required to avoid this kind of a ransomware attack. And to a larger extent, there are always a forensic which comes after that. Okay, when it comes forensic, so it will take down to each and every endpoint as well. Okay, even they can blame you also because of your issue or problem or your behavior, this got impacted. So this can go into that level kind of a thing as well. Okay, and in terms of, if we got some ransomware, how do we mitigate it actually? How do we come out of that? I'm just trying to share you 2 minutes insight into it. First of all, we should, isolate the environment. Say for example, if your laptop got infected, immediately, put the network out of it. Don't turn off the system. Okay, just disconnect the network connectivity. Never ever shut down your system. Okay, just break the connectivity. Why I'm saying? Because when the forensic will happen, it will actually fetch the logs and the details from your memory actually. Why I'm saying, we should not shut down the system because as soon as you shut down the system, your memory will have some data which will be lost actually. You might have read about volatile, non-volatile memory. So those kind of things will come into it. So it is always suggested, never ever shut down the system in case of a ransomware attack. Always disconnect the network. Okay, so that once the forensic comes in, then they will actually investigate it. And then there are few more steps like contaminate and but never ever pay to the ransomware guy actually. Don't do that kind of a mistake. That is the biggest mistake. If you do that, So these are the and obviously do the regular backups of whatever the data you have at any time. So backups, regular backups are obviously required to come out of that recovery.
So we are almost done here. It's not a optional, okay? Runtime security is very paramount for each and every organization now and then. It's not an optional at all. So, in the learner perspective, we need to think in such a way. Ultimate goal is to protect the product or any financial, any health-related data that has to go through these processes. And so, is there any questions? Any last questions? I'm not going to yes, please.
So I'm a part of PKI consortium. So within PKI consortium, there's a group dedicatedly working on zero trust architecture. So out of there, the recent discussion that I was involved in was how can we connect service mesh with zero trust architecture. So a few of the folks were asking, is service mesh enough for zero trust architecture when we only talk about the security of pods and containers, not going towards the infrastructure or hardware. Yeah. So the question is service mesh enough for zero trust architecture for pods or containers?
I may not be able to answer it because I don't know the architecture. So once we see the architecture, probably then I think I should be able to answer it.
So it's I think you're going to mesh
Istio and all.
Sorry?
Istio and all.
Okay. So that's what the three critical component in the your zero trust architecture, right? So you need to verify each and every level, whether outside, inside. You need to follow that step. Then you need to talk about the least privilege mechanism. Okay. Then you need to always verify each and every level of your authentication mechanism. Correct. So these are the three principles you need to follow to minimize any kind of impact. Maybe I may not be connecting with your exact questions. Okay, but these are the principles you need to follow. It's a practice actually. It's a practice you need to follow for everyone. So it's all about your decision making from the top-down approach, correct? So that is what these practices is coming into the now as a standard. So I hope we can meet your expectations. Correct? I think you.
Yeah, CB.
Yeah, CB. Yeah.
How you control that? Like what kind of CB, and that CB is from a third party in the supply chain. Some CB from third party organizations, and
That is where I think integrity comes into the picture, wherein you need to only follow the trusted source. Okay, say for example, if you are downloading something from Google, okay, you need to download thing from Google.com only. Okay, not from the third party. If you bring it from Microsoft, you need to follow that Microsoft, and there is a signature also which stays actually. There's a digital signature. So digital signature will actually, tell the authenticity and the integrity that it is from that particular. So that kind of a thing we can control by that. I mean, we should have that kind of a mindset, and good, and you're asking this question, so that kind of mindset we should have. There are many occasions where even I think SolarWind was one of the organizations that got impacted because of this case only. Thank you.
Okay, you can conclude the call for the day, session for the day.
Thank you so much
Thank you so much, everyone. Nice to have you here, and I think we can over to the next speaker.
Thank you.
Thank you so much for that session. That was really very insightful. And of course, you have a lot of experience that shows the amount of information that we got to experience today. So thanks a lot. So before lunch, we just have to do one more session, then we'll proceed for lunch. So I'll invite Khushi and Satyam to do their session. We have some time. You can. It's fine. Come.
खुला हुआ है
Good afternoon, everyone. Today we are going to talk about the paradigm shift in networking from kernel to cloud. I'm Kushi, and my partner in crisis and in presentation is Satyam Dubey, and we are EBPF researchers at LGCore organization. So let's start our presentation. First, I want to talk about the fundamental question, like how does the kernel network stack currently works? Traditionally, how it goes, how our packet goes into the system. So when our packet arrives at our NIC, then it is passed to NIC driver. After that, the packet is traversed to XTP, where in NIC driver only. After that, the socket buffer is allocated to that, and the packet traverses into the kernel network stack. In kernel network stack layers, from link layer to network layer and protocol layer. And after a while, it finally reaches its destination, that is application layer in user space. So it takes a lots of checks and time to process the packet. So it is time consuming and with full of safety checks. So applications that needs faster response, and they don't need to consume that much time. So they have an issue. The latency for each packet in the stack is inefficient for them, and the latency is a real bottleneck for them. So the question is, and the idea is, can we cut the line in kernel network stack where we don't need to compromise the system, but can we fasten the system? And the solution is yes, we can bypassing these costly kernel operations where possible. So the main part is how can we do the kernel bypass? So first, let's understand what is kernel bypass. Sorry, at its name sound, kernel bypass. It is exactly like its sound. We are bypassing the kernel stack. This is our kernel stack, and we are bypassing it completely. And we are doing what? From NIC to direct user space. So it is basically our main focus. How can we do this? How can we achieve this kernel bypass? So the main technologies that are playing in this market are eBPF and DPDK. eBPF works within the kernel. It optimizes the performance within the kernel and beyond. Where DPDK, it is a direct high-speed packet performance processing in user space. What it does is, it takes the packet from NIC and directly delivers it to user space, bypassing the whole kernel. Whereas eBPF works inside the kernel, but at NIC driver level, at XTP, or you can attach it somewhere in the kernel stack as well. But for the latest, if you need low latency, you can attach it at XTP level, and you can work within the kernel but bypass the major network layer that consumes your time. So let's talk about these technologies. The first one is eBPF. As the last presentation, we're talking about runtime security. And eBPF is one of the tools that gives that runtime security. And it is like the Swiss Army knife of the Linux kernel. Swiss Army knife represents that it is a multi-purpose but compact tool that can stay in your kernel but without changing the kernel source code. So the purpose of this eBPF program is we can run our sandbox program in kernel space without changing the kernel source code. So what can we do is we can write our user space program. We can write our eBPF program in user space, and then we can compile the program using CLang. If we are writing in C, we can write eBPF program in Go, Rust, or Python as well. But then we need to use different compilers, as your language. So after that, the program is like compiled into the bytecode, and the program is like mainly distributed in two parts. The first one is program that includes instruction sets and all. The second one is maps. Maps are the common like shared memory space between the kernel space and the user space. This is our kernel space and this is our user space. So it is a common memory space for them. After that, the first thing is like we are working inside our kernel. So the main thing is security. If the program is not secure, it can like do bad things in our kernel and crashes our system. So eBPF verifiers work comes into play, and what it does it verifies the program. Whether the program is safe to run inside your kernel, it checks for infinite loops or any other kind of things, like any instruction that can cause damage to your kernel or anything. After that, when the program is verified and eBPF says okay, and it gives a thumbs up, after that the program is just in time compiled using JIT compiler. This JIT compiler like automates the system and attaches the eBPF program for the intended hook point. It can be XTP, it can be softmates, it can be access calls or etc. As what we like. There are multiple hooks where we can like attach our eBPF program. Let's have a look at those hooks as well. These are the hook points where we can attach our eBPF program, and like we can monitor, trace, or observe our packets, how are they moving within the kernel network stack or from NIC to our user space application. So the lowest and the fastest one is XTP. It is at NIC driver level. So it is used for high performance packet filtering. After that comes the traffic control, where we can hook at ingress and egress at TC. It is for traffic shaping. After that, we can hook at socket layer. It is for packet inspection. And then we can hook at C groups as well, at ingress and egress hooks for container traffic control. After that, we can do at tracing as well, at K probes, U probes, or trace points for system code tracing. And as I have mentioned, XTP is the fastest. Let's have a look at it as well. It is the fastest packet processing hook in the Linux kernel. And how the packet flows into that, after NIC, at NIC driver, the eBPF program is attached at our XTP layer. After that, the socket buffer is allocated. So it follows the zero copy mechanism. Our packet is not copied in our memory. So the memory is not allocated to the packet. So it comes before that. That's why it follows zero copy mechanism. And why you should opt for XTP, as it is the earliest interception point, runs at NIC driver level, even before socket buffer is allocated. So zero copy mechanism. You can opt for XTP. It bypasses the costly layers like NetFilter and IP tables, and mostly like whole kernel network stack is bypassed in the XTP level. So you can opt for that as well. And at XTP level, we can give verdicts to our packet. Like these are the four main verdicts we can do with our packet. Like we can drop the packet, we can pass the packet, we can redirect the packet, and we can transfer the packet to the same interface. So these are the operations that we can perform with our packet at XTP level. And let's have a look at like XTP also have like different operations. You can do like first one is native mode. You can run XTP in native mode. It is the fastest. It directly runs in your NIC driver, but it needs some support from driver. It needs IXTDE to run this native mode. Whereas generic is like it is universal. It doesn't need any kind of like more specification or something. It works on default interfaces. So it is slower as well. It is more more overhead. Whereas it is also executed in our kernel path, but after the socket buffer is allocated. So it doesn't follow the zero copy mechanism. It is a fallback mode for the XTP. We can use this one while like in development phase or in debugging phase, but not like in production phase. After that, we have offloaded mode. It is the fastest among them. but it is hardware dependent. That is its limitation. It needs smart NIC to operate in this mode. But it is the fastest, so if someone can afford smart NICs, so they can achieve the fastest speed in this area. And if you want to know more about XTP and eBPF in network performance, you can visit my blog at in Medium. That blog goes by unlocking network performance with XTP and eBPF, and it is by KCL17. And the next one is DPD. It is like total kernel bypass. It doesn't go through any kind of things. When the packet arrives at NIC, the NIC is bound to the user space director directly, and memory is allocated from huge pages for DMA friendly zero copy buffers. But it requires dedicated CPU cores for consistent performance. But it is the fastest, but it requires something to be that fastest. It required NIC, as NIC is binding to your user space application, so it required that binding. It requires huge pages. That is also its part for memory. It requires dedicated CPU cores, and good luck if your NUMA configuration is off, then you have to put a lot of effort to implement this system. So that comes to our next step. What we should implement, eBPF at XTP, or we should opt for DPDK. The location for them is eBPF works inside the kernel, whereas DPDK is who is the kernel. I'll directly transfer the packet into the user space. It is a set of user space libraries, so it directly attaches our NIC to the user space. No kernel interference. Then the packet path is before the socket buffer is allocated, it monitors the packet, it traces the packet. But if you go for DPDK, it fully bypasses the kernel, so direct NIC access. Performance wise, eBPF at XTP high. It is high comparatively, but have as well as lower CPU usage. But for DPDK, it is ultra high, but it requires CPU core trainings. So the next point is resources needs. For XTP, in native mode, it can work in your default kernel drivers. But if you go for DPDK, it requires huge pages, driver bindings, and dedicated cores as well. And as for deployment part, DPDK is suited for bare metal, and it requires a lot of effort in DPD development part as well. Whereas eBPF is easy to deploy on any standard Linux distros or VMs or containers. Then next part is when to use eBPF at XTP versus DPDK. If you want something smart, plus safe, plus integrated, it can be integrated in your already built application. Then you should opt for eBPF at XTP. But if you want something fast at raw speed from direct NIC to your user application, and as well as it needed dedicated CPU cores, and it requires some manual labor to access the things, then you should opt for DPDK as well. And for the scenarios, if you want something speedy and system safety as well, then you should opt for eBPF at XTP. If you need to filter, redirect, or monitor packets in production, and if you are running in Kubernetes cluster or cloud virtual machine where full bypass is not feasible, then you can go for eBPF at XTP. Whereas if you need to handle multiple million packets of at ultra low latency, and you are running on bare metal with and you need full control over that, and you are okay with managing CPU pinnings, memory isolation, and the full stack, then you should opt for DPDK, as it has raw speed and it is fast compared to the eBPF at XTP. Whereas if you opt for offloaded mode, it is also as much fast as it is. So you should opt for that. And now Satyam will take over and he will explain the applications where we have implemented eBPF.
Hello guys, my name is Satyam, and it was nice that Khushi explained all the deep architecture and working of eBPF and DPDK. But now I'd like to go into the aspect of applications a bit more, because okay, eBPF makes things fast, but now where are you going to apply that? So the first application I want you to introduce is the use of eBPF in 5G. So I've also written a detailed blog regarding that, where I've shared all the metrics and the performance ratios between different kinds of UPFs. So I'll come to that. So I like to introduce you with the UPF, which is the user plane function in 5G. Now, what it does is, so there are two planes, as you could see in this diagram, a control plane and the user plane. So your user equipment, which is your mobile phones, laptops, etc. At the initial stage, the control plane is responsible to verify your subscriber identity and provide an IPv4 to your device, or IPv6 as well, if that's in your package. And after that, the user plane function, it is the one which is responsible for routing your traffic to the internet. So let me give you more detail about it. If you could see this N4 interface over here that connects the SMF to the UPF, this N4 interface is the interface through which the UPF gets all the instructions about the PDRs, FARs, and QoS, which are nothing but some packet detection rules and forward action rules and your QoS enforcement rules. So you have different types of QoS in your 5G network, and how your packet should be routed, and if there are multiple packets coming from different users, which has the highest precedence to be routed to the DN. So those all processing is done at UPF, and from your user equipment, the packet goes to the RAM, and then by the N3 interface that carries the GTP packets, which is the GPRS tunneling protocol, very famous in the 3GPP standards. So through that interface, UPF gets the packet, and after that it routes it to the DN. And this packet that's going to the DN is generally an uplink traffic, and the traffic that's coming from the internet to your devices, that's known as a downlink traffic. Now, this was the introductory part. Now moving forward, let's discuss on the responsibilities that UPF holds. So every time your traffic goes to UPF, it has some responsibilities to fulfill, all of which are GPU encapsulation and decapsulation. So as I made you familiarized with the N3 interface where the GTP packets are coming, those packets are to be decapsulated off the GTP headers, and then after decapsulation, that uplink packet is routed to the data network, which is the internet or a voice call. If you're doing, you'll be using IMS in that case. Now, next is IP forwarding and NATing. Of course, when the decapsulation is completed, your packet needs to be NATed over to the gateway, and then it's forwarded to the internet. Next is the QoS and traffic classification. So because there is a lot of traffic coming at the UPF from various devices, there's a lot of QoS handling to be done at that layer, because you have to make sure that the packets with the higher precedence go before the packets having a low precedence. At the same time, making sure the packets with the lower precedence don't lose their time to live, which is, if you're familiar with protocols, there is a general time to live present in every packet headers that states that this packet is valid for only that particular amount of time. After that, it has to vanish from the stack because it could cause some congestion problems in the routers. Next is traffic classification, we talked about it, and usage metering. So of course, the amount of data that you utilize, it has to be metered in some way, and that method is implemented at UPF. So UPF sends periodic messages to SMF informing that how much data that you have utilized at that particular amount of time. So that is done by usage metering. Next is actually quite interesting concept, lawful interception, but I wouldn't go into the details of it as of now, but give a brief interview about it. Lawful interception means if I have the right permissions from the governors and the ISPs could actually make a clone of your packet and deduce everything, all of your traffic, where it is headed to, where it is coming from, and every detail about your traffic could be exposed to the ISP. Now, of course, this is a very interesting point to discuss on, but currently let's leave it at that, because there are some governing bodies that need to be involved in order to perform this. Generally, this is done for security reasons, for some suspicious activity going on with some ISP providers. So what do we expect of the UPF to give us in the form of QoS. So if you want a good UPF that could fulfill our requirements and the responsibilities listed here, we need to ensure that UPF could provide us very good latency, which is covered in one of the QoS types, which is URLLC. That means ultra reliable low latency communication. And the next is enhanced mobile broadband. Just to clarify on the aspect of broadband and latency. So latency means from a start point to an endpoint, how much time a packet takes to reach from a start point and to the endpoint. That is latency, which is the amount of time it takes. And broadband means at one single amount of time, how much packets could you send in the network? So if you can send at the same time, let's say 50 MB of packets, that's your broadband. And the amount of time it takes for that packet to reach its destination, that's your latency. So we need to reduce latency and we need high broadbands. And next is the MMTC, which is massive machine type communication. That's widely used in the IoT devices. And the next very important aspect is horizontal scalability. That means if you have a UPF running on your premise or cloud server, you want to scale that UPF to let's say, or 4 UPFs. So that should be easy with your UPF application, so that it could scale to your on-premise or your cloud platforms. And as per the traffic increases, you could easily scale over more UPFs and handle that traffic separately. Next, cloud native architecture. As I mentioned, if you want to deploy it on clouds, it should be cloud friendly. And next is hardware agnostic. Now, what this particularly means is, if you want to deploy a UPF and handle such large amount of traffic, it should not be compulsory that you always depend on some specific type of hardware only. That totally takes you away from the cloud platforms, because you'll be always asking for those particular types of NICs, that particular specification. So it's important that your UPF is hardware agnostic. That means it is not much dependent on your hardware specifications and some particular adjustments that are needed to be made to the hardware prior to the deployment of UPF. Keeping these things in mind, let's move to the next slide. We have some traditional UPFs already in the market, and I want to talk about on their limitations for the moment. If you talk about UPF in the application layer, where the packet processing is done completely at the application layer. So what happens is your packet travels through the kernel stack to the UPS application. What this does is, this adds the time for processing that particular packet. And this in turn increases your latency as well. So as I've listed over here, context switching overhead, of course, you're moving from kernel space to user space. You'll have to context switch a lot of times per packet too. And higher latency because you'll need more processing time. Next is the network stack overhead, where Khushi mentioned some time before, where she was talking about the security checks and all. So next part, where we're covering performance with DPDK, I would like to talk about its lack in some aspects. Though DPDK gets very good performance because it's bypassing the whole kernel using the PMDs, but it's not cloud native friendly. So you need some specialized NICs, and you'll have to make some prior arrangements before deploying your UPF. So it's not cloud native friendly, and you cannot scale it suddenly. You'll have to make a lot of hardware arrangements prior to its scaling. Now, keeping those two things in mind, what we can see is when we're moving towards performance, we are lacking scalability and cloud native architecture. When we're moving towards cloud native architecture, we are lacking performance. So what we need is a solution that could fulfill both the categories. Moving to the next slide. Introducing eBPF-based UPFs. Now, what is happening over here is, first, I'd like to introduce two major components over here. One is the PFCP manager, the other is the UPF data path manager. Now, what the PFCP manager does is, I talked about the N4 interface before, where the SMF is connected to the UPF through the N4 interface. All the instructions that the UPF gets from SMF, all those PFCP messages are passed by the PFCP manager. And our eBPF data path manager does what is, it loads and attaches our eBPF programs to the N3 and N6 interfaces. Now, one more important thing that our eBPF data path manager does is, because you have the message being passed at the user space and our programs are running in the kernel space, you need some middleman that could help you communicate regarding the rules. And there comes the eBPF maps. And these eBPF maps are filled with all those packet detection rules, FARs and QoS, and that is filled by eBPF data path manager. Now, as you can see, because I'll get more deep into the architecture, but let's talk about the advantages with eBPF. There are no context switches now, because all the processing is done in the kernel layer, and no context switches decreases your time of processing each packet. That in turn reduces your latency. And there is zero memory copy as well. And by zero memory copy, I mean whenever packet reaches your RX queue, there is a socket buffer allotted to each packet. And this socket buffer is not allotted in case of XDP native mode. So this is very important point that you note. It only works for XDP native mode and not the generic mode, because there the socket buffer is allotted and performance is not that good. Now moving to the next slide. So the architecture looks kind of like this. What was happening in the application-based UPS is this: generally the packet would reach the user space for being processed and being applied all those QoS enforcement rules. But now what happens is, as soon as the packet reaches from the GNB to the L3 interface, the HTTP program over here is triggered, and that HTTP program decapsulates the packets from the JTP headers, and the packet is forwarded to the gateway, then to the internet. And now this uplink is complete, and then when the packet comes from the internet, it comes to the gateway, and then through the gateway to the N6 interface. And again, as it's coming to the N6 interface, the HTTP program is triggered, and it again encapsulates the GTP headers, sending the packet to the GTP, and then back to your user devices. So what's happening now here is, HTTP, which is the starting, the main entry point of whenever a packet comes to your system. Over there itself, we are intercepting the packet, not allotting any socket buffers. In turn, we are doing zero memory copy, and the processing is very fast. And all this is done at the kernel layer. So there is no context switch between the kernel space and the user space. That gives very good performance. So now let's do a comparison of all the three types that we discussed. The traditional UPS, they have kernel stack overhead, but DPDK and eBPF, they don't have that. And the hardware dependency, traditional UPS, because they are working on applications, so you don't have such dependency for that. And for DPDK, there's a lot of dependency in the hardware. And for HTTP, again, because in HTTP native mode, the dependency is on your network driver, and HTTP is supported by various network drivers, and one famous one is Veth, and Kubernetes is very friendly with Veth pairs because it uses it a lot with its pods network namespaces. So you can run HTTP native mode in Kubernetes pods as well. And moving to the cloud native support, we got the solution of being cloud native friendly and performance friendly with our HTTP based UPF that fulfills your need for performance as well as cloud native architecture. So also scalability is possible now because as I talked about, Kubernetes pods are friendly with HTTP native mode. You could easily scale the UPS to, as long as your hardware can go that way, you could scale it to whatever value you want. Now moving to the next part, yeah, you could check over to my blog to get all the specs that I have benchmarked regarding different UPS. So if you're interested, please go ahead. Now I'd like to move to my next application. This one's quite recent and very interesting. I would like to talk about is, if you guys are familiar with socket splicing, is anyone familiar with that? Okay, fine. Let me explain it a bit. What generally happens is when two sockets are communicating in a network, this network stack is properly followed at that point of time. So what happens is, let's say we have a pod A and pod B, and the pod A sends the message to pod B. The message goes through the network stack, and all those socket buffers are allotted. But using socket splicing, what we are trying to achieve is, we are trying to achieve a way so that the escape buffers are again not allotted and we could gain better performance in that point of view. So there are certain methods in the kernel already for socket splicing, which is a splice syscall that we do in the kernel, if you're aware about that. What it generally creates is a socket pair and a pipe. So a pipe is generally what, when we use this, for a parent socket to communicate with a child socket, we use one pipe, which is a simplex mode of communication, where only the parent can send messages to the child, and the child cannot respond with any messages. So to create this pipe, create this communication as a duplex form, we create a socket pair where we introduce two pipes. And these pipes are generally used by the splice syscall in the kernel. But there's a limitation to it because it's not intelligent. What it will do is it will just route the packet from this socket where you'll give the file descriptor for that to the other socket where you have a file descriptor for that. And you cannot do any kind of filtering or you cannot write any kind of logic for this. But this problem can be solved if you're using eBPF. Now what this does is the eBPF SOP map provides a programmable interface for this and giving the same kind of performance that you get with the splice syscall. What it does is, now look at this architecture. I have used SCP and SMF for my test, but you could use any pod for that matter and any pod that suits your application. Now what the architecture looks like this. When the SCP application, in my case, sends any packet over, generally what happens is it goes through the network stack, and in the network stack the socket buffer is allotted. Then through its network interface, it goes to the other pod's network namespace and then climbing its stack again. So you're having the socket buffer allotted over here and over here as well. So this imposes a lot of latency and it costs you your bandwidth. What we do now is we create a SOP ops program, and this shared socket application does what is it attaches a SOP ops program to both the pods sockets. What it does is, this is limited to only TCP for currently, and whenever a TCP SYN packet is sent from pod A to pod B, there's a connect syscall that is triggered. And for every connect syscall event, the SOP ops program is triggered. What it does is, now it extracts this packet and it checks its context and it extracts the remote IP, that means the destination IP it wants to reach. And from that, it makes a key value pair of that socket and its socket cookie in the SOP map. Now what socket cookie is? Socket cookie is basically a unique identifier for every socket in your kernel. And that socket cookie is extracted by our SOP ops program and written over to the SOP map. Now what the next interesting thing that happens is, the SOP ops program till now did only this much, that it wrote the SCP socket cookie and the SMF socket cookie in the SOP map. The next program that is attached is known as the SK message program. This is very special type of program because it is attached to an eBPF map itself. Generally, eBPF programs are attached to some trace points or hook points like HTTP, but this one is attached to an eBPF map itself. So what happens is, when this program is attached to this eBPF map, for all the socket cookies that are present in this eBPF map, if any TCP payload passes through that socket, this program is triggered. Now, what logic I have written in this program is for it to redirect this packet to this remote IP using the eBPF map. So now the architecture has taken a shift. When the packet is coming from the SCP application, it is intercepted over here and sent over to the SOP map, and from the SOP map to the SMS network namespace. So this gives a performance boost, and I'd like to show you its demo. I have a video regarding it. So yeah, if the screen is available, now we are checking if there is any BPF program already loaded in the kernel. So you could see all the C groups are present, which are generally for the Kubernetes pods, but there is no eBPF program as of now. And now we are going to run a test on our two pods, where SMF will be our SOP server, and this is our server's IP. And we are going to daemonize it in the TCP protocol. So yeah, this is the server's IP, and we are going to run SOP server command. and SCP is going to be our client. So you can see the server is up now. It will listen to TCP traffic, and in SCP we are going to ping the server for 3 seconds, where we are given using the time flag, and the traffic will be of TCP type. So now you can see the test has started. You wait for 3 seconds, and here are the results, where the latency without eBPF is 26 microseconds on average, and the total amount of messages sent are 48,973. Now moving on to the next part, where we'll be using eBPF now. So what we are going to do is, I have a script for this where I give the container's name for it to attach the programs. So I gave SMF and SCP over here, and you could see the program is now being loaded. And also we could have a look at the maps over here. You can see the sock map is also present in the kernel. Now, as BPF is loaded and attached, we are going to see the results again with eBPF. So you can see these are the logs coming in the trace pipes that says redirected successfully. So I have generated them for debugging. And now the latency is reduced to 16 microseconds. And the total messages sent are 78,000. So this is a 60% performance boost. In terms of latency has been reduced by 60%, and the messages have increased by 60%. So yeah, if you couldn't catch the details, you could have a look over here. Without eBPF, we had 26 microseconds as the latency, and with eBPF, we have 16 microseconds. So there are some limitations, although we got this performance boost currently, but there are limitations for this project. It only works for TCP as of now, because SK messages are limited to working on TCP payloads only. This limitation is imposed by the kernel. So we cannot change it. If you want to, you'll have to fork the Linux kernel and do the changes yourself and sell it, or go ahead and do whatever you want to do with that. But the other dependency we have is same hardware requirements. So if you're familiar with C groups, currently the programs are attached to the C groups, and C groups should be present in that same hardware. If you're trying to connect a server which is somewhere else to another server which is somewhere in California or somewhere, if you want to perform shared socket solution over there, you cannot do that. It has to be the same hardware, and the same hardware has those C groups. Then only the sock map will have the messages. Next is, I will not call it a limitation, but rather a use of, rather a kind of different perspective in the use case. Because you cannot TCP dump the traffic now. As I told you, the network stack is completely bypassed. And because it is bypassed, you cannot do TCP dump because it works at the lower layer of the network stack itself. But one solution what you could do is, because you want to monitor the traffic, the eBPF programs forwards the traffic to a metric server as well, simultaneously when the packets are transferred to the pod B. So that's a solution you could come up with if you want to monitor the traffic. Now, this is a much detailed slide. I won't go into the depths of it, but just to make you aware of what we were doing currently. The first one was the shared socket implementation, where we were sending the packet to this local pod, and we were using BPF ingress redirect flag. It typically means that this packet that is redirected to another socket, it is going into its ingress queue rather than egress. That's also optional. If you want to perform that, you could do all these kinds of variations with this program. Now moving to the next slide. Yeah, I can understand that. Let's move to the next slide. Why not XDP? So you might be wondering, when I was talking about UPF, I was going on and on about XDP this, XDP that, XDP native. But when I came to sockets, suddenly I stopped talking about XDP. To answer this question, let me bring you back to the diagram. So you could see XDP is lying deep over here at the bottom of the layer. And when we use XDP for this solution, what happens is, as the packet is traversing down from the socket, the SK buffer has already been allotted. Because because escape buffer is allotted during egress or during during ingress or during egress. So now at the point of egress, after it leaves the socket, the escape buffer is allotted. Now there's nothing to protect. You have already lost the memory, you have already gone through the kernel stack, and at the last layer you're saying you want XTP. And fun fact, XTP does not work on egress. So any packet that's going out of the pod, any XTP program will not trigger for that matter. And nextly, if you will ever use XTP, it would only trigger after it has reached the SMF pod and when it's going into the egress queue. And at that point alone, you could trigger the XTP program. So you've already seen we have compromised one socket buffer on this pod. So that's why SK message program is the way to go for socket-based communications, because then only you could avoid assigning socket buffers to either that and this pod. So that was by me. Yeah, I know you guys are hungry and sorry for taking a lot of time. And thank you guys. If you have any questions, you can ask us. Okay, thank you.
Okay, so just before lunch, we just need to do one thing. One of our speakers has to go due to a family commitment, so I just would like to invite him once over. Please come. Thank you so much for the session. It was really insightful. This is small gift from the
Thank you. Thanks.
Okay, now I would request all of you to please proceed for lunch, and then we will have the next two sessions after. Okay, thank you.
सर कहाँ का है?
आप भी करना है
Mostly learning I have focused on the runtime security, which was on given by Gentle, and the lots of things are learned that apart from that, the last year done by it was good and it's equivalent by us. And these things I have to explore and now but if we go we have to explore all those things. And the first session, it was something new for me. It was informative. Yes, yeah. It was the meeting and all. So at that time, I'll go to the big and that explore the steps and all those things, the codes and etc. And explore more what can I do that. But we can
Hi. How is it going over there? How is it going over there?
We are here to learn how the RAG is created. Basically, and also learn about how we can implement RAG on Yes, it is very informative. Yes. As we have also worked on BCP and we are also using Cortex AI, so it is very interesting. I have learned that RAG implementation for using of Cortex AI to implement RAG and then how we can use and use RAG on it.
It's clear. What will that's very good. Into the sponsor,
It's going fantastic. The only thing was that I but it is going it's going really good, and now in the second session, which was kind of non-technical, it was more of theoretical, but I really enjoyed it. So it's going really good, and we have, I guess, 2 more sessions left, which are going to be around BBC and yeah, I'm really excited about those things. I have learned. So the first thing was that this rare kind of thing, which was the first session, right? It was very fascinating. It was also new to me. And in the second session, I learned about very basic security. We talked about like what precautions you should take and what yeah, this was fantastic. That was non-technical. So it was great for me. And yeah, the third session was a bit more technical, I would say. So in that session, we did a lot of stuff around. Yeah, it was technical, but it was also fantastic. I would say. Yeah. So that's it. Thank you.
Hi. The session was great and I got to learn a lot of new things here. I was not familiar with RAG architecture.
Actually, how is the
session is going on very great and I got to know and understand a lot of new technologies that I was not aware of, like RAG architecture, I was not aware of. So it was very fantastic for me.
That's quite a new thing for
Yeah, it was quite new with hands-on practice. That was quite an interesting and interacting, we can say, talk.
it was.
Yeah.
And this was like from this overall workshop over here.
The first thing is learn from basics. As the second top implements those basics, I go to know about the Lord. And the second thing is we can say you should have you should be known what is going inside the market, like what are the things and the technologies that are working right now, that are going on right now. Like get familiar with the tools and technologies. And the third thing is do start interaction. Do the information. Yeah, we can say that. Definitely.
Yes.
Thank you.
Thanks. Thanks. Shiva.
सर नमस्कार सर नोएडा नोएडा हाँ जी सर ये हमारे सरकार का नहीं सर अपनी शादी सर उनकी कौन सारी सर ठीक है सर मैं नोएडा सर सर ठीक है मुझे काम सर हाँ सर सर ठीक है रामनगर हाँ अभी का अच्छा ठीक है रेडी को आपसे ले जाओगे और मुझे बना दे सर रामनगर से ठीक है ठीक है ठीक है ओके थैंक यू
Compared to this side.
फोटो ले लें सेल्फी ले लो तो बाकी तो वीडियोस मिल जाएंगे
ये पूरे इंडिया के लिए सिक्योरिटी के लिए शायद जिस चैप्टर को मैंने करता हूँ न्यू दिल्ली वाला ये दिल्ली नहीं बट हम ऑल ओवर आप मुझे पिक कर दें या बाकी को भी कर सकते हैं बाकी कॉलेज कॉलेज आपको कितने लोग रिकॉर्ड करेंगे रन करो एक तो मेरे लैपटॉप पे रिकॉर्ड मेरे इसके ये तो भाई कैसे मैंने इंस्टॉल किया सब क्लोज हो
नहीं यहाँ पे कॉन्टेक्ट कर सकते हो क्यों बहुत सारे टाइम्स
रिकॉर्ड कर लेगा एप्पल है ना हो जाएगा ठीक
कौन से ऐप से
नहीं ये देख कमांड शिफ्ट 5
अच्छा अच्छा ठीक है ठीक है
ठीक है रिकॉर्ड कर पर मेक श्योर कि हो ठीक वो ज्यादा से
ठीक है हाँ मैं भी सही कर रहा हूँ
ठीक है करते हैं चलो
और करना है ऑपरेशन और करना है कहाँ पर यहीं पे और मैं कुछ और जो उसको रैंडम लोगों से ही बात करना अभी तो माइक से मुझे आगे नहीं हो रहा ना कि मेरी आवाज जा रही है कि नहीं जा रही है
और मैं जो रोटेशन में बनाया
फुटबॉल रोटेशन मैं ज्यादा मुझे पता है कि उसकी लेफ्ट होल्ड मुझे पता
तो हम ज्यादा तो हिट कर रहे हैं सॉफ्टवेयर में ज्यादा
इधर से रिकॉर्ड करते हैं ये तो जो कोशिश करना कि इसके क्लोज रहो इसके पास ताकि ये वॉइस पे रिकॉर्ड वॉइस होती है इसमें विंडो शिफ्ट फाइल से हाँ होती है बाय डिफॉल्ट एक बार टेस्ट रिकॉर्ड ये ऑप्शंस 5 सेकंड में डिले कर ये ठीक है डिले नहीं करना अच्छा ये तो रिकॉर्डिंग दूर से करें हेलो हेलो ठीक है बस इसी तरह मोशन लगा
क्या कौन सा
मेरा प्रो है कितने लोग देख रहे हैं इसको
चलो मैं एक बार बुला लेता हूँ
2 लोग देख रहे हैं ठीक है
2 तो एक बार आगे बढ़ हाँ तू लगा के रख ले जब तक आ रहा हूँ Hello, guys. Just an announcement for all the attendees. Before you leave, please, we have a special gift for all the attendees. So collect it from Avinash and Nikhil. They're right there at the entrance. Okay. So before you leave, just inform me or just go over there and collect your gifts. Okay. Okay, so we are starting with the session now, and our next talk will be given by Aditya Goranga. But before that, one of our speakers actually, I would just like to invite Nitin on the stage. Nitin on the stage. We have a small token of appreciation. Thank you so much. Aditya, please.
Hello. Okay, so hello everyone. I hope you all are doing well. So today's topic is going to be a bit different from other topics, and I think it's one of the most these days. That is related to post-quantum cryptography, but the title is Dead Keys Tell No Tales, Post-Quantum Adventure. So first of all, I would like to ask how many of you have idea about post-quantum cryptography? Cryptography? Cryptography, okay. It's fine, no worries. So I think the first thing we need to discuss is what is even post-quantum cryptography. So for that, I would like to introduce my two cats, Alice and Bob. They are very naughty, I would say. So yeah, because the first thing that comes into our mind when we talk about security is boring. So that's why I brought my two cats with me, who will try to tell you about post-quantum cryptography. Okay, so why post-quantum cryptography? For that, we firstly need to understand why even cryptography. So here there are two cats, Alice and Bob. So they are like sitting over the different edge of internet. And now Alice wants to send a message saying, "Hi Bob," and it reads the message. So they are sitting on the opposite side of the internet. So Alice sends a message, "Hi Bob." Now they thought that it's a good world. Nobody is going to disturb their privacy and all. Nobody don't care about what they are even talking about. But unfortunately, very bad guy appeared into the picture. So here's my friend Shankar, who I always introduce in my PPT. So Shankar is a very bad guy. So what he does is he disrupts their privacy. He checks the message, and it's not his fault because the message that was sent by Alice to the Bob was in plain text. So Shankar can already see what the message is. Now, so if I'm talking to someone, I don't want a third person to jump into the picture and see what exactly I'm talking about. So that's why Alice and Bob cried a bit. Then they said what to do. So they came up with the idea, let's use cryptography, and to more specific, classical cryptography. So what happens in classical cryptography is Alice now has a public key. She encrypts or locks the message in such a way that only Bob can see it, and now the plain text is not in plain text anymore. So the good thing is now only Bob can unlock this message or decrypt this message using a private key. So that's the thing, that's the idea behind classical cryptography. And now the message is not in plain text, it's in ciphertext format. So the "Hi Bob" has been changed to "meow meow," which nobody else can understand that. So that's where Shankar cried, because he cannot understand what's going on now that they are using classical cryptography. So, but Shankar said, "I will take revenge." So the story doesn't end here. He says, "I will take revenge." And then after a few years, now Alice and Bob thought like everything is going well. We have classical cryptography, a message is in ciphertext format. So everything is going fine. But you know how Shankar is. The good thing and the bad thing about Shankar is he never forgets to take revenge. So a few years later, now Shankar has turned evil. Let's throw the horns as well. And now he brings a quantum computer, and not just a simple quantum computer, it's a very powerful one. And using this, he once again decrypts the message. I mean, he can bring back the same message that was encrypted. So the message that was in ciphertext, it's still once again in plain text. So it's plain text, which means not at all secure. And once again, you know the story, Alice and Bob cried again. But this time they thought, okay, we need something very strong, very secure. So what can we do? So they came up with another idea. They said, let's use post-quantum cryptography. That's PQC. Now, good thing about PQC is the ciphertext that was broken by the cryptographically relevant quantum computers, it can once again encrypt it. So now this time, Alice has a post-quantum public key and Bob has a post-quantum private key. Now, once again, this made the message ciphertext. It's again in ciphertext format. And now not even quantum computer can break it. So it's not in plain text anymore. It's in ciphertext format. Once again, meow meows. So that's the idea behind this. So Shankar cried again. So finally he realized that he has lost. So he lost again. But now Shankar has finally understood that there's no worth in fighting this war. So all is well if it ends well. So, but you know, the problem is, okay, we can say, some people still say that we don't have quantum computers till now. So why are we even talking about the flow that I discussed earlier. There is no quantum computer. But yeah, I understand with the perspective, but there's another problem, bigger problem than quantum computer. The problem is store now decrypt later, and which is also sometimes known by the word harvest now decrypt later. So now what's this store now and decrypt later? So let us suppose this is the timeline, and for example it's 2025. So somewhere in the world your data is being collected, and it's not simple data. Let's say it's encrypted data. And you don't mind because it's an encrypted format. So you are saying, okay, it's already in ciphertext format. Nobody can even understand it. So we'll stay calm. We won't do anything. But the thing is, even if it's an encrypted format, let's suppose that in near future, maybe in 2030, 2035, or let's say it even takes 5 years later than that, a quantum computer is available. Now, what capabilities this quantum computer has? It can decrypt all the encrypted message. So the data that was collected somewhere, for example, China and other countries usually do this. They are collecting your encrypted data, and it's a fact. So no idea of like running away from this fact. So they will decrypt. Quantum computer will decrypt all your encrypted message. So that's the threat. Now what we have is decrypted message. Now what we can do? That's the main idea. Let's say your data is still there, encrypted format. And let's say you adopt PQC at this time, for example, 2025. Now, after the day you adopt post-quantum cryptography, all your data will still be protected no matter how strong of a quantum computer arrives. And so this is safe now, which was earlier not safe. The quantum computer could have decrypted all your messages. But the good thing is you've adopted PQC, so your data is still protected. And unfortunately, I'm really sorry, but we can't do anything with the data that is already lost. So, but thing is, what can we do? So the idea is adopt PQC as soon as possible. Even though quantum computers are still not there, but harvest now decrypt later is one of the major things that's already raising us to not procrastinate further and let's adopt PQC as soon as possible. Because even if you start this idea, it will take a lot of years, right? So at least we need to start with this intent. Okay, there is some quantum computer, there is some PQC, and let's do something about it. And bigger problem is procrastination, or something that I say cryptocrastination, that is delaying the process of even migrating to post-quantum cryptography from your classical cryptography. So currently the basis of internet was in classical cryptography, even your WhatsApp, your complete infrastructure network. It was dependent on the very core cryptography schemes that were classical. And now those are not safe against quantum computer. For that, we need PQC. That's the main idea. I hope you understand this. So this is what industry also realized, and that's where the first Preparedness Act was implemented by the US government. The president of US in 2022, he passed this Quantum Computing Cybersecurity Preparedness Act, where he asked all the management officials to migrate to PQC as soon as the NIST are there with their new standardization. So NIST is a standardized body who take care of your all the cryptography schemes, all the security protocols, whatever algorithms that you're using. So they said once NIST implement their PQC within a year, you also migrate your officials and management things to PQC. And this is where NIST came up with the new standardization algorithms. And this is one of the screenshots that I've taken from those specifications and publications. You can see some of the algorithms are like elliptic curve Diffie-Hellman. I hope it's visible. Okay, yes. So you can see elliptic curve Diffie-Hellman, RSA. This is the basis of internet. Everything that you're running right now is dependent on this. And what's the problem? You can see this side. NIST says that these will be deprecated in 2030 and completely disallowed after 2035. And trust me, like 5 years in crypto world is nothing. From like migrating from SHA-1 to SHA-2, SHA-3, it took probably like 10 years. So these are the basis of internet, and now it's not completely safe. So you could imagine what the threat is. And that's why some big players like GSMA, IBM, and Vodafone came up with this post-quantum telco network task force dedicatedly on the post-quantum thing. And GSMA last year in 4th October 2024, they came up with their publications of post-quantum cryptography solutions, how you all guys, how any telco or any normal domain can migrate to PQC. Just give an idea, not complete steps, okay, do this, but at least give an idea. So, and OpenSSL, which I'm a part of, they released this year OpenSSL 3.5, which now supports MLChem, MLDSA, and all those algorithms. And my favorite one is Post-Quantum Cryptography Alliance, because I personally know the people from Post-Quantum Cryptography Alliance, and especially the vice chair of PQCA is such a great guy, and really great vice chair of PQCA. So, anyways, so I forgot to introduce myself. Hey, it's me, Aditya Goranga, and yeah, that's me. And I'm the vice chair of PQCA, Post-Quantum Cryptography Alliance, which is under Linux Foundation. And I represent small businesses and individuals at OpenSSL. So small businesses, all the businesses who have those companies who have less than 100 members, I represent them, as well as the whole individual community. So that's me. And do you want to know more about PQC industry? Because this is something, especially this year and last year, everyone is talking about PQC. So I created one doc that I was preparing something for. So this was like so this is like a PQC world doc that I was creating. And you can see some of the big players. For example, you can see AWS, the progress is really fast. And they, even though they have like FIPS validated PQC algorithms, they have AWS LC that they have like integrated with S2 and TLS, which is like the basis of AWS service, whatever you want to use. And those have been integrated with PQCP, which is under PQCA. So that's something that I look into. AWS is doing some great thing. IBM is like they were the first one who introduced these post-quantum algorithms, that is MLChem and MLDSA. So they are doing a lot of stuff. I will like personally working with them. And Google have Crystal Kyber implementation. They have ARTS protocol, which is not something everyone is doing. And they have this Flink library. Recently, I think last month, I saw some of the posts. They've implemented post-quantum algorithms into this open source library called Tink. You can already Google it and find whatever the things are working on. And these Microsoft, it's average, but Microsoft latest news, last month they integrated PQC in the Windows operating system. So that's one of the great things. Apple is really fast. So PQ3 protocol, recently they have integrated that with iMessage. And they have this really good CryptoKit, which is good for API and for PQC algorithms. So you're seeing this MLChem, right? MLChem, and you will also see Kyber. MLChem and Kyber are same, but what are these? These are the post-quantum algorithms. The one that made my cats happy. So these are those algorithms, MLChem. And Intel is doing great work. Intel is focusing more on the IPsec. They have this NetSec accelerator these days, and they are working with Arcade company. I think it's company from London. So they have like union, memorandum of union, and they are working on accelerating IPsec using post-quantum algorithms. NVIDIA, there's a guy, the project manager of their CUPPC, I'm personally working with them. So out of all these ones, the most performance that I've gained with the MLChem PQC algorithm. So when you talk about cryptography, it's like key generation. You have public key, private key. You have to encrypt the message. You have to decrypt the message. And there's that thing, encapsulation, decapsulation. CUPPC is like at the top, I think. I have generated using I was working with this GPU, GS200 and GB200 and H100. They were like 100 million keys generation operations within a second. So it's really good. But only thing is you need to have like powerful GPUs. So that's the thing. Samsung is doing good. AMD is kind of slow. And these banking, financial services, it's because defense and banking and finance, these sector needs to be very secure because these are the basis of all your transaction. Defense is very important. So JP Morgan, HSBC, Goldman Sachs, Citigroup, yes. So they are already working on PQC, and some testing and measurement companies like Keysight and VIAV, they are also working. They have now solution platform that are dedicatedly focusing on the PQC algorithms. And Cloudflare, good thing about Cloudflare is now this says that 35% of their traffic is now encrypted using PQC. So that is great thing. Cisco is doing fine. And these are all the companies who are working on all those things. Anyway, so the main idea behind showing this was the industry, the large businesses are focusing on this. So everyone needs to be clear about, need to take care of this. Small businesses, they are more of like customer focuses. So once their client and customer says, okay, migrate to PQC, then only they will do it. Anyways, but there are a lot of startups these years, like probably more than 100 who working on PQC. So, okay. So after this, so you might have heard about like Chinese-based Salt Typhoon attacks, which has already affected 9 telecom companies. And this was only using classical computers. So you could imagine how impactful these attacks would be when you have a very strong quantum computer. So these are some of the examples, for example, that could be possible in the near future, like quantum in the middle attack. You have quantum powered IMSI catchers. You have token hijacking, DOS. Some of are like even classical attacks, but just to give two ideas, these are like combination of quantum attacks and classical attacks, because attacks would be highly effective with quantum computers. So just to give a basic overview, and there are like hundreds of more attacks that could be possible. It would probably take months if we discuss all those things, but just have a look at like what could be some of the main attacks that could be possible. And at this condition, we have understood what the problem is. So now what's the solution? Because the main thing that we need to care about is solution. Okay, so I work for open source. I work for PQC and OpenSSL, so it's my duty to like popularize these open source projects which are already solving this problem. And if you're solving a problem once, then you don't need to solve it again and again using any closed source or whatever. You could do some invention or on top of those. So these are some of the open source libraries that I work with. Those supports post-quantum cryptography. First one is OpenSSL, release 3.5 did a great job. And LibOQS, these are like from working from 2000 something. These are like the most proficient one who are working on this PQC. So LibOQS is Open Quantum Safe, PQCP. So these two libraries are already under us at Post-Quantum Cryptography Alliance. CUPQC is very good for acceleration, because one of the major problems that your clients would say is, okay, we are migrating to PQC, but the key sizes, it will take a lot of time and all those things. But don't worry, CUPQC will solve some of the problems. And nowadays, every workload is you're working on GPU, so why not use it for cryptography also? So these are a bunch of libraries that you can try based on your implementation, whether you want to do your implementation in Java, then use Bouncy SL. If it's in Go, you use Cloudflare Circle, otherwise C, C++, OpenSSL, LibOQS. So it depends on your use cases, okay? And we have already applied this libraries with some open source projects, like these HexaABPF, Aether and all. So we've already implemented this. And these libraries are dependent on some standards, because you can't just say, okay, my algorithm is post-quantum safe, everyone should apply it. The world doesn't work this way. So you need to have some standardized body. Even it works, standardization, for example, nowadays they're working on AI security. They're saying we need to have some standardized body, otherwise people will do some bad things and all. So these are the standard bodies. The main one is NIST FIPS 203, 204, 205. It basically tells about like which algorithms that you need to use. That is MLChem, MLDSA, SLSDSA, and this year they added HQC. So these are some of the standards, and these are some of the publication. If your company or even you as an individual, you're trying to look into the PQC, so you need to follow these specifications. And IETF, how many of you know about IETF, RFCs? Okay, so IETF is like the basis of your internet, who are like designing your architecturing your protocols, the basis of your internet. So they have a bunch of RFCs which will tell how to integrate this PQC into, for example, your TLS, for example, your OAuth, for example, your VPN and all. So you need to follow this. And these are MITRE FIDE framework. You probably know about MITRE, so these are all good. And what we are doing under Linux Foundation, so we have launched Post-Quantum Cryptography Alliance last year, and 3 of the projects are part of it. First is Open Quantum Safe, PQCP, and one other is working group tooling that works on your CBOM kit. Now, what is CBOM? You probably know about SBOM or BOM, bill of material, software bill of material. CBOM is cryptographic bill of material. So we are saying we need to migrate to PQC, but how to do it? Firstly, we need to have a cryptographic inventory just to improve the visibility. Okay, these are the algorithms that we are using. It's like your bill of material that only talks about cryptography. Because you can't migrate into PQC because if you don't know what to migrate, right? So firstly we need to identify what to migrate. That will be done by CBOM kit that was part of IBM. last month they donated this project IBM CBOM kit to PQCA under us. So it's a very good thing. And these are the open source library under the PQCA, and we have integrated with these other open source projects. You can do this. Standards are these. And what about OpenSSL? I already told. OpenSSL released 3.5. So you could see MLChem is ready, and they also say that it's production ready. So very good. MLDSA, SLS, and they have 3.6 release there where they'll be adding LMS, XMSS. They are all algorithms, PQC algorithms. So earlier they were like 48 algorithms, but they chose like which is the best one. So there were like 3 to 4 rounds, and finally they said MLChem, MLDSA, SLS, will be the standardized one. If you want to migrate to PQC, you could definitely use it. And this year they added HQC and LMS, XMSS there for signing and authentication. So good. And in the priorities, OpenSSL priorities, they also say that we will add furthermore PQC algorithms. So these are the things. And yes, PQC migration examples. But before that, I talked about CBOM, right? Cryptography Bill of Material. So I tested that CBOM kit, and it generates this cryptographic inventory like this. So let me share. So you can see that. So I use that CBOM kit in my source code. It scans all your source code, and then it gives the result like 11.9% of your code that cryptography is based on your source code is not quantum safe, and some of the part is quantum safe. So it tells these are the assets, and these are not quantum safe. And if your source code or your libraries are quantum safe, then it will give that 20.6% is quantum safe. This is the use of CBOM kit, and it will also give a list. So firstly, we did a POC. There was some 5G core company. So firstly we scanned their code, and these were the algorithms: RSA 204, RSA elliptic curves. These are not quantum safe. And then we migrated to post quantum, and this was the CBOM that we generated. You can see MLDSA, MLChem. You can see the checkbox. So these are now quantum safe. So this was done by us, where we migrated already running 5G core into post quantum core. And these are, it will also tell the algorithm that I'm using why it's non-quantum safe, how is it quantum safe. So these are all the things of CBOM kit. I think you should also try it out. And okay, now we have understood about PQC. What was the major problem? How is the solutions? Now let's try to understand those things through some examples. Okay. So this is one of the slides that I took from Shubham's slide. So this is the classical core security architecture. You don't need to understand NRF, all those things. Don't worry about it. What I want you is to focus on the left side. So these are the interfaces that are connected. These are all like cloud-based, service-based architecture, right? And it's not something that you need to only apply on 5G core. We were like had clients for 5G core, so that was some of the POC that we created. So what I want you to focus is on this side, that is MTLS. So the red interfaces that is connected, it is connected using MTLS. Now any application that you use in Kubernetes host, any cloud deployments, you probably use MTLS between them, because otherwise any like data in transit, all the messages that you're sending will be non-encrypted, and you don't want to do this, right? So for this security, you apply MTLS, which by default is not quantum safe. There's a threat. You probably use some of your components might use elliptic curve with DRBG. So it's not quantum safe. Once again, you use basic IPsec, VPN all over your infrastructure and even between your components. That's not quantum safe. ES128, it's okay. So people have like mixed opinion about ES128. This is the symmetric cryptography. It's fine. I think not the big problem, but anyway, if there's a problem, you just need to increase your symmetric key size. And then you have OAuth 2.0. This is probably like authorization. Whenever you sign into somewhere, they say like, let's generate OAuth tokens for this session for this much validity and all. That is not quantum safe. DDLS and IPsec. So these are the real world examples where these protocols are being used, and these are not quantum safe at all. And that is the story of every project that you are using these days. But for these, we need to have a specific strategy, migration strategy and roadmap. So for that specific example, we use something like for service-based interface communication, they were firstly using MTLS. Now we have PQ-MTLS. When I say PQ-MTLS, it's MTLS 1.3 with PQ support, because you don't need to confuse that PQ-MTLS is a new algorithm. No, it's not. It's just MTLS 1.3 with post-quantum support. So in the Cypher suite, you have MLCAM, MLDSA, all those things. For digital signatures, that is used for your authentication and certification and all. Firstly, you use classical signature scheme these days, and in that case, MLDSA will be used in future, or if in present you want to do the migration. For some interfaces, IPsec, you need to use post-quantum IPsec. It's just IKV2 with post-quantum support. All those things, and like in some cases, we even had ECIES scheme. It's dependent on elliptic curve. So for that, you need to have post-quantum architecture, OAuth, authorization. Everybody use. You probably have used Keycloak for token generation and all. OAuth, by default, it uses classical algorithms like RSA, elliptic curve. That will be migrated to post-quantum OAuth. In that case, you will have to use MLDSA. And fortunately, we were the first one who implemented post-quantum support in OAuth, so it's a good thing. The last two rows are blurred out because these are not very important. AES, you could do AES 256, and DRBG, it's fine, but just to have more secure and more randomness, you probably need to use DRNG and QRNG. DRB, so every cryptography algorithms need some seeds and random numbers to generate cryptographic keys, right? So for that case, we need to have a very random, strong source, and these days you use quantum computing for these random number generations. So this was the strategy that we applied. Now, this was all the knowledge that we gathered, but knowledge doesn't mean anything if you don't apply it somewhere. So after applying this strategy, the architecture that we came with was this post-quantum code. Once again, you don't need to focus on that side, just focus on this side. So earlier it was MTLS, it was not quantum safe. Now we are migrated with PQ-MTLS, and also we had QRNG. There was this startup company from UK, Quantum Dice. So we're using their PCI-based QRNG. So now PQ-MTLS is quantum safe because it uses post-quantum algorithms. UDM, which was specifically focusing on the elliptic curve, now it uses MLCAM. It's quantum safe. PQ-IPsec, it's quantum safe. AES 256, up to you. Token-based authorization is now quantum safe because we are using PQ, and these are all the things. So that is one of the examples how we did it. And let's take all those things one by one. For example, PQ-MTLS, that comes under service-based interface. So when you zoom in into the PQ-MTLS part, it's bunch of cryptography things which you don't need to care about. Your cryptographers and your security architects and security engineers would take care of this, but only focus on this part where it says MLDSA, MLCAM, because in future, in recent years, these will be something that you would be highlighted the most for this part. So now algorithms have been changed. They use MLDSA, MLCAM. These are a bunch of external information. And these were the log screenshot that I took from one of our deployments. So you can see with the when you start a TLS session, transport layer security, TLS session, then you have client hello message, client those messages. So it was running between two ports. So you can see the client's supported curve, it's MLCAM now. It's already also use hybrid MLCAM. So some people say we don't completely want to migrate to post-quantum cryptography. So what can we do? Because you don't trust PQC completely. So we say use hybrid models. You use existing classical algorithms, and then you also attach them with post-quantum cryptography algorithm. So X25519 is like an elliptic curve, classical curve that is running on your TLS session when you watch YouTube and other things. And then we have added MLCAM. So this is the hybrid approach that we see. These are some of the TCP dump. These are like a Wireshark screenshot. So you can see in the key share it says X25519 Kyber. Kyber is MLCAM. So this was standardized at that time. And MLDSA and all those things. This is PQIES. So it's not easy that you can only do TLS, you can only do IPsec, you can only do OAuth. That's not all about security. Some components are still there who have a different architecture for securing them. So if there is something that architecture that's very proprietary to you, then you need to have a complete different architecture. So we did several changes for this. It's very complex. We won't go into much into about this. These are some of the profile we added. These are the standardized profile for let's say telecom security. So these are standardized. So every telecom operators that you have today, they will have to follow these ones, profile A and profile B. But this is not quantum safe. So every call that you're making that are like dependent on these. But now in future, you will probably have to add these profiles like MLChem, elliptic curve, SHA, key derivative, bunch of cryptographic terms. This is PQIPsec. So what I realized, like everybody knows about VPN, right? Everybody knows about VPN. So VPN these days are like it uses IKEv2, Internet Key Exchange Version 2. So how can we make IKEv2 quantum safe? Because you said like in this architecture also we had a firewall. So firewall is something every company has, every infrastructure security, everyone like use this. This is like a gateway part of every network. So how can we make that firewall quantum safe, and how can we make a VPN, for example, VPN quantum safe? For VPN, you will have to create this tunnel. So we are using open source project called Strongsman. They added MLChem. So when you create a VPN IKEv2, there's a bunch of key exchanges, bunch of handshakes and all. Now what we did multiple key exchanges. So for example, in some cases you were using classical, and then we can say 5 key exchanges on top of that we did through MLChem. So these are like, you need to do bunch of multiple key exchanges. This is under IETF. So we follow 858, 8788, something RFC is there. So we do that. And this is even what Cisco do. Cisco and VRV do. So we also follow that. And that's a very good thing. If the workload is too much, there are a bunch of IPsec tunnels, then you could use eBPF to offload this XFRM policies at your XGP socket. So it could like increase your performance, you know. And it's also obviously everyone knows like you can use eBPF for observability. So you can do all those things. And this is post-quantum zero trust architecture. So in the previous talk, they talk about zero trust architecture. So we have added a flavor of post-quantum. So the mantra of post-quantum zero trust architecture says that every component within or outside your network is not safe by default and should not be trusted by default. And in near future, they might also be using quantum computing. So that is the slogan and the mantra that we did with post-quantum zero trust architecture. And I personally say sometimes that never let your wife read NIST SP 800-207. So anybody knows about this special publication 800-207? So when you Google it, it will say NIST SP 800-207 is zero trust architecture. So if your wife will read it, so you can imagine like within your inside your home and outside your home, you will not be trusted by default. So never let your any relatives or wife or children read about the specifications. Yeah. So I'll probably zoom it in. So these are some of the authorization tokens that we generate. It's not specific to whatever bunch of NRFCP that I have written. It is applicable everywhere. So earlier we were using, let's do NRF post-quantum JWT token. Let's generate them. But now JWT token is by default using classical cryptography. It's not quantum safe. Now we will say let's generate post-quantum JWT token. So one tokenization authorization server will generate post-quantum token, and it will give to the client and server, producer and consumer, whatever we want to say. So these were some of the model C, model D. Once the registration MTLS layer is there, done, after that you need to also use this validity tokens. So MTLS with OAuth, now PQMTLS with post-quantum OAuth 2.0. So these are some of the things. And we also had one example. So we completely changed the architecture of ORAN. I know not many of people know this. We completely changed this architecture to quantum secure ORAN, and for this I was also invited at ORAN Working Group 11. So we got like after doing this, we got like 3 big clients. So it's something really important. So idea is similar. You have a bunch of interfaces, because when you go with service-based architecture and microservices and all, so you break your components into multiple parts. And the more you break into them multiple pieces, it's good for interoperability, it's good for scalability, but it also opens the gate for multiple attacks and all. So all the interfaces, we will have to use these post-quantum algorithms. So these were some of the examples. I hope you understood. Thank you. Any questions? Yes. I hope it didn't go above your head. So, any questions? Yes.
For this, you are putting more payloads into the encryption, correct? So is this really not impacting to the engine or the communication between the two clients, correct? So how you can resolve this issue or reduce it? Because you are pressurizing on the payloads, then your algorithm works very fast, but it will take time, correct? If we want to decrypt that process, so it will take time, or how it is? So that's my question.
Yeah, so I would say for encryption, I think most people get confused when we say post-quantum cryptography. They will say that even for encryption we are using some other algorithms, but at the end of the day for encryption we are still using AES. But the thing is how to generate those keys, those similar keys on both ends. For that we are using post-quantum for that part. So it generates, MLChem is the protocol that uses key encapsulation messages. It generates those key and then key exchange. So earlier the idea was for key exchanges, it was taking more time, but now the algorithms is designed in such a way that it's taking somewhere similar time to the elliptic curve, the classical one, and in some cases getting more performance. But the bad thing is the resources. So the key sizes now is like 4 times than what it actually was. So that is the thing, resources, it will take more things. Encryption for AES, the encryption thing will still be the same, but you create a basis for encryption also. You generate keys, key exchange. That thing will take more resources. Timing would be good. Just in case of VPN, we are doing more exchange, right? So it's something right now we are doing multiple exchanges, but now IETF is focusing more on IPsec. So all those workloads will now be done within 1 or 2 exchanges. That's like the standard IKV2 exchanges. So it won't take much exchanges. So timing is fine, I would say. Only resources is like your certificate would be taking more size. Your keys would be taking more size. Encryption would still be the same. Key exchanges would be similar, in some cases faster. Your resources would be utilized.
This particular cryptography method is really standardized, or it is
PQC. Okay. This PQC post-quantum algorithm that we are using, these are all NIST standardized. So NIST is like a NSA, US government who are standardizing it. Every government is following it. Even let's say if you don't want to use these algorithms, there are some other algorithms that is standardized by everyone. Europe government is also following this. Australian government is also following this. Your bunch of different government following this. Chinese government, they are saying we will not trust to the US government. This needs, so they are generating their own algorithms. Japan is saying, okay, we'll use these algorithms, but not the one that they have shortlisted. In other list that I said, there are some few more, but these are prioritized. So they're using NTI, some of the algorithms. The Indian government is also, they are saying like, we use Kyber and all this. So probably, you know, QNU labs, the startups who are working on this cryptography, so they are also focusing on this. So it's somehow standardized. Even whatever you are using, TLS, VPN, currently these are also NIST standardized. Even zero trust architecture, this is also NIST standardized. So the same body is also standardizing these algorithms.
But it is not yet standardized for this particular cryptography, correct?
Particular cryptography, PQC is standardized. And what US government is saying that after 2027, we won't be accepting any protocol, any software which don't use these algorithms, PQC algorithms. So they have given a timeline, migration strategy. Every government is saying, let's do it by 2030, let's do it by 2027, and by 2035, we will won't be using these classical algorithms. So this is something important. but you don't need to completely remove your classical algorithms. You can do crypto agility. What we say crypto agility is the infrastructure code still be the same. On top of that, you will add some other algorithm, PQC algorithms. So crypto agility, if for example your code is hard coded, for example you're using RSA, you've written RSA code, you're not using any library. So the simple solution is use a library. Indirection is always the key, right? If you're facing any problem, do it in an indirect way. So crypto agility is the term that you will see. Just use some of the libraries, but it's not that easy. As I said, some architectures still need proprietary design, and also even your firewall company, even your load balancer proxy. If you want to do on infrastructure layer, that will be changed. If you want to do on API level, that will be changed. If you want to do code level, if you are going with the zero trust architecture, so every level is important.
So what are the challenges we are going to face?
Yes.
Out of these.
So the first challenge is procrastination. Second is how to convince your CISOs. Because so few of the funds that we got is like they were saying let's create a POC because we need to convince our CISO, and so that is like everybody will have to create their POC, and now you want to design a POC according to everyone. So that's the thing. Other thing is architecture design. So for telco, for example, I'll give an example. For telco, we thought, okay, we'll use these libraries and all, but in most of the cases, their code is hard-coded, handwritten. So they're not using any library. That is one of the major problem. Resources utilization, that is also the problem. Supply chain, for example, your software is dependent on vendor A, vendor B, vendor C, vendor D, vendor E, F, and your vendor D is very intelligent. He says, let's migrate to PQC. But it's also dependent on other vendors, right? So you also need to convince these vendors in order to have interoperability. There are a bunch of lists, and hopefully you're not conservative, so I think you'll probably do it. Yes. Yeah.
So I wanted to ask, do you have any special hardware when you talk about PQC? Because I read one of your posts, you were talking about NVIDIA using some special hardware. It's a two-part question. And if someone now wants to look into quantum computing, not PQC in general, but in general quantum computing, where should we start and how should we, build something, a solution or a startup around it? What would you recommend? And your capstone really cute.
Yeah. So first question is hardware specific. Not everyone wants to be hardware specific. So we do software implementation, software acceleration. That is like do the native. For example, you do WebAssembly, you do it C native. You want to do it with the architecture of, let's say, ARM-based implementation. You want to C90 implementation. So we are already doing that in PQCP, and we say that it's already enterprise level, so you can do. But still, because everybody can't afford hardwares, but somewhere they fascinate over it, so they like it. So if you want to do hardware acceleration, it will give very optimized performance. In that case, you can use GPUs from NVIDIA. So they have now dedicated CUDA library for PQC. So you can use any not random GPU, but GPU that supports 70, SM70, 80, 85, 60 architecture. And the best one that I used was GS200. That's like somehow I got the access of GS200 and GB200. So they will millions of pigeons within a second. So, and also, as I said, Intel is also using some NetSec accelerator. So they've created like proprietary accelerator. It's the accelerator, but you have seen E200, E210 NIC, Columnville NICs. So they've converted those NICs into accelerator. They're using those things. Second is, I also personally do quantum computing stuff. I genuinely like it. The thing you could do is, you could probably try Qiskit. You could probably try CUDA Q. You could probably try some of the tools. An Indian startup, National Quantum Mission, I think, how much is the budget? Somewhere like, earlier it was like 8,000 crores. And now they're doing 500 crores for this quantum. And I've seen many initiatives by government of India for PQC startups. They're giving somewhere like 500 crore, 100 crores to some of the startups. India, at the current moment, quantum computing is really booming, and government is also supporting it. And also for PQC. Yes, thank you. Any more questions? Okay, thank you.
Thank you so much, Aditya. And now we just have the last session, and it will be given by Shubham Kumar. Shubham, can you please come on stage? See laptop now? इसका कर देना।
Hello.
Well, just a heads up for the audience. Shubham is actually technically very, very sound, and he's also my good friend. So I request you to bombard him with as many questions and trouble him as much as possible. He genuinely can give you a lot of knowledge. So.
So hey everyone, and today we are going to discuss about something that is not talked about before. So blockchain use case in telecom. So before that, a quick introduction about me. So hey, this is Shubham Kumar. I'm a 2024 graduate. I completed my bachelor's from University of Delhi, and I'm in the telecom industry for the last 4 years. And my expertise lies in O-RAN and 5G security. And I have also expertise in integrating different techs into the telecom architecture, just like the pieces in the puzzle. And currently, I'm serving as a mentor in the Linux Foundation Decentralized Trust and also a member of the OpenSSL Foundation. So in today's agenda, we are going to talk about a little bit about the blockchain part. Then what is its use case in the telecom industry? How it was presented in the research papers, and what is real world implementations. Then some benefits and challenges. Then one of the most important part, the proposed project that I have presented in the eligibility mentorship program. Then about this architecture and the solution it brings it with it. Then lastly, we have the future direction. What are the other implementation of the blockchain in the telecom industries? Then finally, the Q&A session. So blockchain. So what we understand from the blockchain is, let's consider a company where there's employees and all have access to the database of the company. However, in the blockchain, what happens, this database is stored in each of the computer instead of a centralized authority, a centralized location. And if you want to change something, you have to agree with everyone that I want to change this database. And if they all, through an algorithm, some majority of people agree that this kind of data should be accepted, then it will be updated in all database at a single time. Then, so this is kind of how blockchain works. First of all, let's say there's, for example, when A wants to send a transaction to the B. So first of all, it makes a transaction proposal. It was first authenticated. Then this transaction is created into a block. Then it was sent to all the nodes, all the participants in the network. Then this particular block was validated by a majority portion of the participants. Then after that, it was updated in the blockchain, and then further it was updated in all the networks. in all the nodes databases, which is also called ledger. So even though if I say everyone knows about blockchain, at least the word, they don't know about the technology, but they know about what blockchain is, and also know about a lot of things in telecom, because we all using mobile devices and 5G networks. So why we can't see something implementation of these two technologies? Why it is so rare? Why there is no such implementation right now? No real world examples. So based on my research on 30 plus research papers, how blockchain is implemented in the telecom architecture. So what I found, what is shortcomings there, they have the limited scope, like some research papers are only focus on some roaming and handover scenarios, then they are misattributed. Okay, so some research papers are good, they are producing good conclusions, but what is the major problem is that they focus on something other than the blockchain. The majority portion is covered by, let's say, cryptography, the zero trust architecture, the asymmetric encryption. Then the lack of the implementation, some ideas are good, but they don't show what kind of protocols, how they would going to implement this kind of things. Then they have the contradictory 5G design philosophy. See, in the 5G, they are all, everything is service-based architecture, everything is disaggregated, but these papers are showing results based on aggregating the components into a single architecture and then producing something that disrupt the conventional architecture of the 5G itself. Then again, so introducing blockchain also brings latency and security problems. So no vendor would like to introduce it into its architecture, because see, every vendor wants its customers to be happy. And then the paradox. See, in the architecture, what happens? Let me explain it through an example. So some of the papers state that before the transaction happens between two entities, there should be a pre-trusted channel established between, let's say, GNode B and the 5G core. So it's kind of something that is against blockchain, because blockchain is something decentralized and it should not be pre-trusted before the actual transaction happens. So is it? So it's not like there's no real implementation itself. There is a popular implementation, that is Devi, not Devi. So Devi is a kind of system where individual corporates, communities establish their own network, decentralized network. It has the ownership. What they have to do, they have to buy the required infrastructure and set up the network, their homes, and also gain something from it. So this is the kind of architecture of Devi architecture, where we have our GUIs, mobiles, and this is something an individual or company adopt a kind of hotspot. Then based on that, it provides free coverage to all users, and by doing so, it gains some crypto rewards in the form of tokens from the operator itself. And this is also a device which is used to test the coverage of the device hotspots. And they also gain some kind of crypto reward, token reward from the operator itself, whoever adopt their infrastructure and technology. So this is one of the beautiful example I can say, because see, in this particular architecture, so this is the company, Fallen Mobile, and what he does, he called every entity in the architecture some kind of related to the flower kind of garden. See, our UIs, our mobiles are hummingbirds, which connected to the flowers. Then these flowers tested by the bumblebees. So this is validator. This is our mobile system. This is hotspot or small cell, and this is the main operator. So it kind of handling things like this. I really like the naming convention of this particular company, so I just showed it. So why one should adopt the Devi network? Because again, so now we have some real life networks like Helium, Pollen Mobiles, Freedom 5, who are doing this kind of thing on a large scale. Then we have token incentives. Whoever adopt this particular infrastructure or technology will be rewarded by some kind of tokens, let's say HNT, PCN. Then the blockchain is only used for the rewards and governance part. The normal traffic goes again by the same data path that actually was going through from the traditional architecture. Then one of the most important part, the self-sustaining model. So in the initial state, you have to do a kind of payment for the hardware. But again, you will be sustaining your own infra model from the self-sustaining model, where you will earn some kind of tokens in response to what you provide services to the users. Then again, the market. But again, there are also some challenges. Yes, I said there is a hardware cost in the initial setup. Then there's a regulatory, because some areas you don't get the spectrum access license. Then there's an internet dependency. Hotspots will still require ISP connections, and limiting the idea of decentralization where everything is distributed between the nodes. Then there's a coverage gap in some kind of uncertain deployments, because you see, if I deploy somewhere in my urban area, you will get more users, whereas in the rural areas, you will be getting very less users. So it's kind of uneven network coverages. Then again, the technical complexity, you have to learn a lot about before deployment. You have to learn about how to deploy, what is the technical things, what I need to do. Then again, there are security risks as well. So this is kind of network. So in the 5G network, some of the operators who provide this, first is the Helium, then the Pollen Mobiles, then the really, again for the Wi-Fi networks, alert. Then LoRaWAN networks, there are some more vendors like Helium, Phone, Chirp, and again some more vendors in it. So before I came here, I set up a decentralized network here. So you can scan this QR code and connect to my decentralized network. I'm just joking, guys. This is my LinkedIn profile. You can connect with me. So this is the most important part, and this is the idea I presented in the LFX mentorship and got selected. So blockchain-based OAuth 2.0 authorization in telecom with Hyperledger Fabric. So this is kind of an end-to-end 5G connection, where we have a 5G core, the software part which actually regulate everything at the back end. There's the internet where we, and here this is the RAN part. So it was kind of split into 3 parts. The first is the radio, you see towers, and there is some software part. And this is finally your devices. So this is kind of a 5G core architecture, and all you need to know about this, there are some kind of nodes, network functions, which are responsible for doing some kind of functionality, specific functionality. Let's say NF is doing mobility kind of things, UDM is storing, NF is authorizing, and there's so many components in it. So this is the classical architecture. What you need to understand, this OAuth 2.0. So OAuth 2.0 is implemented between every network functions. 5G is all about the service-based architecture, where one network function acts as a consumer and the other network function acts as a producer, and they exchange services with each other. So yes, so in the classic architecture, what it actually happens. So first of all, any network function first register with the NRF, and based on the registration successful, it register the profile. Profile is basically the details of the network function in the database. Then, in order to communicate with other network function, it requests a token from the NRF, which is given by the NRF on successful authentication. Then it presents this token in the service request to the NRF producer, and based on that, based on validating the token, it provides subsequent services to the NRF service to consumer. So there is a one problem here. So one of the main problem is single point of failure. So for everything, so for registration, for discovery, for authorization, for token issuance, for validation, everything is dependent on the NRF, a single point of failure. So if NRF compromise if NRF compromise somehow, so there's a slowdown of the network, there will be unauthorized access to the raw NFs, then there should be NF service disruption and a lot of things. So in order to eradicate these things, I have proposed a blockchain-based solution for us. Oh, so before that, a little bit about the Fabric project. So it is an open source distributed ledger technology. Again, same thing, a ledger kind of database that is distributed among the nodes. Then it is a project of the Linux Foundation Hyperledger, and it is a permission network. It kind of it is kind of permission, whereas it is for the private companies, not for a public blockchain. Then there is a pluggable consensus mechanism, Raft and PBFT, then PKI based identity management, where the Fabric has its own certificate based authentication mechanism. So this is the kind of architecture of Fabric. So a client made a transaction proposal to the peers. Peers are also can be endorsed or commit anything. So it checked whether it was a part of the network and some more things. Then it provide back to the client. Then this particular client send it to the ordering service. Ordering service check whether it has the minimum number of endorsers, validate this transaction or not. Then it provide this particular transaction to the committer, which commit all the changes in the blockchain, and then it was circulated back to all the nodes, and then the notification go back to the client. Thus, this transaction has made successful. So this is a blockchain-based solution. So what happens here? First of all, the NF consumer register itself with the NRF. What happens then? The NRF on successful registration, it adds the NF profile, which is the information about the NF consumer, into the blockchain. Then on further, when the NF consumer wants to access some services from the NF producer, it requests the token from the Fabric, not from the NRF this time. And based on that authorization, it access some token and it put it on the service request to the NF producer. And NF producer validate the token and then provide a subsequent services to the consumer. So it eliminates a single point of failure, and the smart contracts are written for all the validation and token issuance part. So some future directions. So some more implementation I have thought about how blockchain can be incorporated in the telecom architecture. So there are also some interfaces in the RAN architecture which uses the Auth 2.0 authorization. So we can again shift the whole authorization part to the blockchain. Second, in the Devi architecture, so there are different RAN components. So there also in the solution architecture where the auth part is included, we can also direct this to the blockchain. Third, in the Devi architecture, the blockchain which are responsible for doing all the governance and the token parts, so it was handled by the Solana. And in my architecture of the blockchain-based auth authorization, there's Fabric. So we can connect these two particular projects to another project which is Smooth, again LMDT project. And then again, so in order to enhance the performance of this, we can again do one more thing. Instead of token validation from this blockchain, we can use a multi-tree which will prove it here without connecting to the blockchain. So it will kind of a step reduce from this particular architecture. And that's it, guys. So this is my QR code. Anyone wants to pay something, so they can pay. Okay, so they will connect with me in the link there. Any questions so far? Yeah.
So this DV that you're talking about, is it for private network or public network? And in both the cases, is it production ready still, or there's still time to make it enterprise level? It will take some time.
Okay, so this is already on the enterprise level. There are a number of companies who are providing this solution. The most popular one is Helium. Second is Freedom 5, then is Poland Mobile. So they are already providing this solution. However, this is not on a big scale. This is still limited to a certain areas. And regarding to the private and public network, so you can use it at anywhere, but the most efficient, the most better way will be around the public network, where you can give access to more users. Because the more the number of users, the maximum number of token, the maximum number of reward you gain from it.
And are these all based on Solana or some?
So Solana, so there's a blockchain which are doing all the governance and the reward part, which is based on the Solana right now. And for the routing purpose, they are also using an open source software, which is Magma. But again, so there are some limitations again with it. But yes, this currently they are using Solana.
Sorry, one last question. Are these Wi-Fi or hotspots or tower or like small cells? What are these?
Okay, so small cell. Let's start with small cell. Small cell has all the components for to be called a RAN. It has all the software part. It has all the radio frequency part, which send the radios to your devices. Wi-Fi is another thing. It is just providing the frequency, the radios part. The other part is still handled by your ISP vendors. And the third thing, what you said?
Wi-Fi hotspot.
Okay, so about the hotspot part, so these particular companies are integrating. It's kind of a small cells. They are also integrating the RAN part as well as the radio frequency part. Some companies, like let's say Freedom 5, they're also introducing the gateway part, which route the traffic of the ISP separately to the ISP network, and the blockchain part to the blockchain.
So they are redirecting the traffic.
All the traffic.
Is it lawful interception?
So it's not kind of lawful interception, because in lawful interception you have particular intercepts on your traffic. It means that your traffic will be copied and sent to some other authority. Whereas in this particular architecture, the ISP traffic will be go to the traditional method to the ISP providers, and the blockchain related traffic, governments and rewards part, are go through this particular gateway part to the blockchain.
Thank you.
Yes.
I have one question regarding blockchain only. And so like when it boomed in 2016, 2017, everyone was talking about blockchain. And right now we see that it's not used in a lot of places. So for sure you have cryptocurrencies and stuff. So like when you talk about use of blockchain in telco, like are there any companies that are actually doing it? Because when we hear about blockchain, a lot of industries use blockchain for like in theoretical purposes. But when it comes to actual practical implementation, many of the markets I've seen, they don't really use blockchain, they just say that they do it. So like, do you have any practical implementation, any company or any existing telco vendor that it is using blockchain right now?
So for the Delhi, yes, there are companies who are doing this. I already stated them. The Helium, the Freedom 5, Poland Mobile, the architecture, you see hummingbirds, flowers. So yes, there are. And apart from that, most of the vendors refuse to adopt it because, again, with the blockchain, there comes latency, the scalability problem. So vendors are currently refusing it. And again, with the adoption of blockchain, let's say in the DEBI architecture, so there is a thing. So customer will provide a services from their end instead of ISP. So there's a kind of downgrading of their market. So generally they don't accept this kind of solution. But again, in the future, it will be a good thing.
And are there any industries or any other way, like you feel that blockchain could, come back into production? As you said, like many are still not accepting the use of blockchain due to latency or any other stuff. So, is there any other way to use decentralized identity except blockchain, or like something that you can comment on?
Decentralized identity. Can you reframe your question?
Like I was asking, so like you're using blockchain for decentralization in this process. So, and telco vendors are not onboarding this kind of a solution for now. So, is there any other way to do what blockchain is doing? Is there any other solution except blockchain?
Means I can bring my own protocol and do something like that.
Yeah. It's just that lot of people in different markets say that we use blockchain, but then again, as you talked about, we are seeing they don't use it in production. So I fail to understand why is it still talked about a lot. Like what's the hype behind it?
If there's need, I guess. Okay, so there are some research papers who are actually using blockchain for their paper. And what I understand from reading this kind of papers, so there's not much need of blockchain. You can achieve the same level of throughput and all kind of latency without blockchain. But again, some kind of just paper they are publishing it with the blockchain. Not exactly necessary, but yeah.
Do you see a future for blockchain?
Yes. So currently Bitcoin are working on the blockchain. Ethereum, you have heard about.
Okay, thank you.
And also, like blockchain is still on the top in so many areas. Actually, like I like to follow my market trends, and this year a lot of even startups and companies, most of the funding they got were some of the blockchain specific. And fortunately, there was a company, Project 11, so they're integrating PQC solutions over this blockchain and even gateway and payment and other things. So they're still in the trend, and I think there's good futures. Although, I think 50 to 60% of the blockchain companies, their ideas are somehow fake, and just for using the word blockchain.
Yeah. So, any more questions, guys? Okay. Thank you, guys.
So thank you so much, Shubham. Now I would just request all the speakers to come on stage.
Please join us.
Please.
Okay, now I will request all the attendees to come on stage. We will have a group photo.
Can I have? So, I'll take 1 second. Thank you so much for joining in today and waiting patiently for your turn, few of the speakers, and I'm sorry if you left early. However, the entire event went really well, and I would like to give special thanks to Vapi and Shivang. Since Vapi has really helped us a lot to make it a successful event, I would like to, give him a little tribute from Courage. Vapi, please be on stage. Thank you. And for Shivang, we would like to. Thank you. Now I request everyone, first of all the speakers, so that we can have a group picture. And later on, I request everybody to join in so that we can have a group photograph.
Sorry. कुछ लोग नीचे
So far,